Welcome, everyone. The event is now live. Chris, please take it away.
Welcome, everyone. My name is Chris Paoli, editor, and I am pleased to be moderating our first session, as well as welcoming you to our multi-cloud trends to watch in 2022 summit, brought to you by VMware. The editorial staff of RedmondMag.com and Virtualization and Cloud Review have worked hard to bring together some of the best independent experts on this topic for this event, so we really hope you enjoy it. Before we start today's event with these 3 great sessions, we do have some announcements. First, we wanted to let you know that this event is being recorded and will be available for future viewing. You'll receive an email when the replay is available, generally within the next few days. Each of today's 3 sessions will be followed by a 5 to 10 minute Q&A, so please be sure to put in your questions into the Q&A area of your console as they come up so we can get them answered for you by our experts. During today's 3rd session, we will be giving away an EXO Pro Blackhawk drone, but you must be present to win, so be sure to stay on for the entire event. Finally, we do have resources from our sponsor, VMware, available on our console right now, so please download and check those out. It's because of VMware's underwriting of this content that we can bring you this summit. So we thank them for their sponsorship and for supporting the community, and ask that you check out those resources so we can bring you more events in the future. Now on to our first session of today's summit, Top Multi-Cloud Trends Impacting Enterprise IT. This session features Howard M. Cohen, Senior Resultant for Tech Channels Partners Result Group. Howard is a 35-plus year executive veteran of the information technology industry who today writes for and about IT Channel. He's a frequent speaker at IT industry events that include Microsoft Inspire, Citrix Synergy Summit, ConnectWise IT Nation, Channel Pro Forums, Cloud Partners Summit, MicroCore One-on-One, and CompTIA ChannelCon. He also frequently hosts and presents webinars for many vendors and publications. Take it away, Howard.
Thank you, Chris, and good morning, everybody. Those of you who've been to my sessions before know that I like to start off with a word. The obvious word for today is multi-cloud, which can be thought of as a word and a half, but it's not to be confused with multi-pass, which was made popular in the Fifth Element. No, we're talking today about multi-cloud. And let's first off start off with our definition. What is multi-cloud? What are we referring to when we talk about multi-cloud? Well, very simply, we're talking about using more than one of the popular clouds at once. For example, you might be using Microsoft Azure for some things and Amazon Web Services for others. You might be using Google and Alibaba or IBM. You might be using all 5 for all we know. So the first question I'd like to answer in terms of setting the context for the trends is why? Why would people go multi-cloud? Isn't one enough? And the answer is that, these are the hyperscalers. Hyperscalers are the large, big, substantial cloud providers. I forgot to mention this. And it's important to bring it up because there are lots of alternative clouds out there too. So if you're using any of the smaller cloud services, that can be considered multi-cloud as well. Why do we use them? Well, we use the multi-cloud for the same reason we go to different department stores. You may be shopping for a shirt and you won't find one at Macy's that you like. You can shop at Amazon. Some of you may not know that Amazon Web Services actually has this small e-commerce retailing department. But some people go to Target, Kohl's. In the old days, we used to go to Century 21. You frequent all of them. It's not like you center in on one and just go there. Well, why do you go to all of them? First and foremost, for the best selection. You may find great shirts at one and great pants at another, great hats at yet another. Tools, you might not be able to find the exact tool you want at one of them, so you go to all of them. The same is true with clouds. Now that we have multiple hyperscalers and multiple alternative clouds, you can pick the services you want from wherever you want to get them. Now, it's not only about what services they each sell. It's also about how each service works. I mean, the same service may work better on one cloud than it does on another. More important, it may work differently. The fact is that you may see the same service listed on each of these clouds, but they each mean a different thing. So you've got to be very, very careful when you're looking and comparing services. They may call different things by the same name. That happens pretty frequently, actually. Another reason that we use multi-cloud is because they're constantly discounting their services. And really, we get to take advantage of their race to the bottom. No sooner do you sign up for artificial intelligence on Amazon than Microsoft cuts their rate on artificial intelligence and you move over there. It really isn't that simple, but there are many services that are really interchangeable and you can switch. This is one of the reasons that many people are bringing along a financial manager onto their cloud team so that they have somebody who can keep track of all the different pricing programs that are being introduced, all the different discounts that are being announced. If you're looking to have the most cost-effective multi-cloud environment, we're talking about large sums of money. So shopping for the best price is a wise thing to do. Well, this is interesting. Okay, one of my effects didn't work. Another reason to use multi-cloud is to avoid vendor lock-in. Everybody talks about this. This has been around for decades. From the beginning of the days when people contracted to develop software, software developers would develop their code in such a way that other people couldn't figure out how they were doing what they were doing. So that if you wanted any upgrades or improvements, you had to come back to them. That has survived to this day. And some of the cloud services are set up so that if you're using one, you really got to use more of them. We're seeing less and less of that because I think the cloud providers are becoming realistic about it. But one good reason to adopt a multi-cloud posture is to avoid that, to avoid being locked in by one vendor, and again, to benefit from their cost competition. The other is you can compare and contrast the services and determine which one is best of breed. That's fantastic. So you pick the one that works best for you in the context of what you're doing. You may launch new applications that, for one reason or another, require a specific service from a specific cloud. More often than not, you may find that it doesn't really require it, but they have some kind of alliance that they say, yeah, you have to use that cloud if you want to use us. The other thing, and this is a functional good reason for using multi-cloud, is that you get more failover options. Now, we've all encountered outages, even on the hyperscalers. Amazon goes down from time to time. Azure has outages from time to time. They're usually geographic. They're usually regional. I don't believe we've ever had the entire all 200 data centers go down for any of them ever. But if you're in a situation where one of them has gone down, you still want to be able to keep working. Well, when you're multi-cloud, you can architect your environment so that everything that you're doing on one cloud can very quickly be failed over to another cloud. So one goes down, you move to another. And then when they come back up, you fail back. That's a great flexibility to have. And again, we're seeing that emerging as more and more of a trend. Excuse me for just a moment, but the console is frozen on me, so I'm just going to do a quick reset. And that's not going well. Oh, here it comes. Sorry about that. We're back in the same place. Okay. Ishana, I'm having a bit of a problem here for some reason. I'm going to try to do this manually. Let's see if it works. Oh, there we go. Okay. So multi-cloud, we're typically referring to the use of multiple public cloud services like Amazon, Google, Azure. Some people get confused between multi-cloud and hybrid cloud. What's the difference? Well, let me start off by saying that I think that the use of hybrid as a word is overused. The reason I say that is, as far as I can tell, everything is hybrid. Okay, officially, hybrid is a combination of public cloud, private cloud, on-prem, multiple different kinds of cloud services. And I challenge you to name any environment that doesn't have more than one of those elements in it today. Most all of us still have some things on-prem, for example. And so, yeah, if everything is hybrid, then why even say it? It's cloud. Maybe the day will come when some of us have nothing but public cloud or nothing but private cloud. That'd be great. But we're not there today. So everything is hybrid. Everything is more than one type of cloud. And yes, you can definitely consider multi-cloud to be hybrid in nature. Multi-cloud is hybrid cloud. And when you think about it, the real question is, so what? What's the big deal? I mean, it's no big deal. It's multi-cloud. You're using services from different places. If you think back, you used to go to a software catalog and you picked out different software products to do the things you needed from different software developers from different places, and you just ran them all in your network. Well, it's pretty much the same, except that instead of buying software, you're subscribing to services, and you can subscribe to them from wherever you want. If you take the ooh-ah out of it, multi-cloud is a natural thing. It makes sense to do it. So my recommendation to everybody is stop trying to make a mountain out of a molehill. It's no big deal. Think about multi-cloud as being a more flexible environment because you're not shopping in one store. You're shopping in all the stores. So it's not really about the cloud itself. It's not about which cloud you're using, how many clouds you use. It's not. As with everything else in IT, it's all about the data. Everything's all about the data. And remember, data only makes money in motion. When we're transferring data from one place to another and selling it or leasing it, when we're transacting business and sharing pricing information with product information, with credit information, and completing a sale, data only makes money when it's in motion. So we can obtain the services needed to make that happen from multiple places to get the most efficient, most cost-effective way of doing these things as we possibly can. What's exciting, and this is where I'm leading to in trends, is that this has given rise to the emergence of a new character. And this character is actually a new member of the C-level. This character is referred to as the Chief Data Officer. We've seen it emerging more in government. Federal government, there's a lot of chief data officers emerging in the DoD and other agencies. This is the seal for the chief data officer of the Commonwealth of Virginia. What is a chief data officer responsible for? What do they do? Well, first and foremost, as it says on the seal, they're responsible for governance of the data. Who gets to use what data, where, when, and how? They're also responsible to establish and enforce policies. And that's a wonderful phrase. You ask people, do you have a policy for that? They'll say, yeah, we have a whole set of policies for how we use data. And then if you ask them the question, how do you enforce that, they kind of just look at you cross-eyed. Most people don't think about the enforcement. Most people really don't do the enforcement. So my recommendation is always think enforcement. It's kind of useless to have a policy unless you're enforcing it. And of course, firewalls and all the other security equipment you have are really tools that are meant to help you enforce your policies. The CDO needs to take an enterprise-wide view of data, not focusing on one set of assets or another, but all of them. This has a lot of interesting tertiary impacts. For example, silos. Data silos just emerge. They happen. And seldom is anybody really watching out for them. The CDO needs to watch out for them. And where it makes sense to eliminate them and to open them up, they do. There are some cases like product design and data like that. Yeah, you want them in a silo. You want them unavailable to others. But more often than not, data should be shared with everybody who needs to use it. And so the CDO gets to make sure that that happens. In essence, they're responsible for the big three: people, the processes, and the technology that are involved in making IT happen. Fundamentally, they are responsible for the total lifecycle management of the data. Is it encrypted at rest and in transit? Is it cataloged? Is it evaluated? Is it secured? They own responsibility for all of that. And the emergence of the CDO is a big trend that we see happening that we recommend every company consider, because really when you come down to it, everything else we do, you have people managing the network, you have people managing software development, you have people managing all kinds of things, but all of that is all about the data. And so somebody should be managing the data. Another thing that people are starting to adopt more and more are cloud-agnostic enterprise management systems and cloud-agnostic interoperability. I mean, that's kind of a redundancy, but interoperability is everything in today's network, in today's internet. You have products from all kinds of manufacturers, software from all kinds of developers, and ultimately hope to make them work well together. You have to keep an eye toward interoperability to make sure that they all work well together. Great to keep them loosely coupled so a failure of one doesn't create a cascade of other failures, but they should be able to interoperate with each other. And in terms of management, we're moving away from using individual tools to manage individual products and services. The best of breed tool is great, but if you have 10 best of breed tools from 10 different manufacturers, that means 10 sets of training, 10 sets of support, and each one has attendant cost. So it's not advantageous necessarily to have a selection of individual best-of-breed tools. Better to have a best-of-breed platform from which you're managing everything and all the tools are designed to work well together. And in the context of multi-cloud, they have to work well with each of the clouds. We're seeing these platforms get better and better at doing this. And so having a cloud in which everything appears in one single pane of glass used to be a pipe dream. Today it's becoming more of a reality. And the trend toward this getting better and better is a very powerful trend, and I recommend that everybody start looking at these platforms and start to evaluate them to determine, if you're going to go multi-cloud, it'd be good to have a platform that can accommodate your ability to see them all in the context of each other. Not for nothing, but you want to be able to compare and contrast their performance in the context of each other. And when you can display them together on one console, it makes it much easier to do that. So cloud-agnostic enterprise management is a big trend as we're moving into 2022. I would be remiss if I didn't talk about security. And here we're talking about core-to-edge security, security of the entire environment. Again, people are using point solutions at the core, point solutions at the edge. We're seeing more and more of a move toward a completely encompassing security strategy that takes care of protecting all of the servers and the storage, and at the same time focuses in on the endpoints and managing them as well. When you have security at both ends, you have security. Otherwise, you simply don't. Security is a chain. It's only as strong as its weakest link. Every link has to be top performing, or else the whole thing isn't working. And so the trend toward enterprise-wide consolidated security is a trend that we're seeing grow bigger and bigger. You can see a theme emerging here. Consolidation of function is a very big theme this year. We're seeing more and more platforms starting to compete with each other to be the platform of choice. Then there's cloud native. I love that term, cloud native. What are we talking about when we talk about cloud native application deployment, development? Used to be that software was developed kind of monolithically as one big block of code. And of course, when everything is dependent on one big block of code, if anything in there fails, it's very likely that it's going to bring down everything. The entire application is going to come down, and nobody will be able to do anything. Seeing that, developers came up with the idea of creating everything as a microservice. Each individual thing you want the software to do lives as a microservice. You put those microservices into containers with all of the resources, all the libraries, everything else they'll need to be able to function. And you instantiate them when you need them. If one of them has a problem, if you have a failure in a microservice, that microservice is destroyed and reinstantiated instantly. And so the resilience of an approach like that is just orders of magnitude better than monolithic code. And so microservices and containers are becoming more and more popular. When you have microservices in containers, you can start to develop software on a continuous basis. That is to say, you start off with developers developing an application with all these microservices. The operations group in your company deploys that to the users. As soon as they deploy it, they start canvassing the users for feedback. They take that feedback back to the developers, who then improve upon the code and create another release of the software. The operators deploy that software. They canvass the users, get the feedback, bring it back to the developers. And the whole process starts again. More code, more improvements, deployment, feedback, development, deployment, feedback. It becomes a circuitous loop. There are companies that are repeating that loop hundreds of times per day. We're not talking about software upgrades every few months. We are talking about software upgrades every few hours, maybe even every few minutes in some cases. So what we're talking about, the CI/CD that you see there, stands for continuous improvement through continuous deployment. And that, of course, is what's given rise to DevOps, combining the function of the development group and the operations group so that having them work together, they can work faster. The whole objective of DevOps is to accelerate the process of achieving continuous improvement through continuous deployment. And in the multi-cloud environment, that's really kind of like water to the fish or the sky to birds. Cloud native was built for a multi-cloud environment where it can travel, it can traverse multiple clouds to get to where it needs to be used in the way that it needs to be used instantaneously. and leveraging the incredible resilience of this approach. So cloud native has been a trend for several years now. We're seeing it accelerate. We're seeing more and more monolithic software go away and be completely reimagined in a cloud native context. If you haven't looked at microservices and containers, if you haven't checked out Docker and Kubernetes and all these other words you hear thrown around, this is a good year to start doing it because it's going to be a competitive differentiator. Accenture really put it well, and I wanted to share the quote with you. They see everybody moving forward to develop completely cloud-native applications and rid themselves of monolithic software. And these cloud-native applications won't really care which cloud they're operating on. They won't be dependent upon a specific cloud. What they point out, and it's a very good thing to point out, is that to function well in a multi-cloud environment and to function well in a cloud-native environment takes a deep knowledge of what's going on in each of those clouds. The more you know about the services that are being made available in each cloud, the better off you are in terms of choosing the right applications, the right platforms for what you want to do. So again, when you're building your cloud team, especially when you go into multi-cloud, you need people on that team who are analysts, and that's what they do. They analyze the different cloud services that are available. They may be from hyperscalers. They may be from alternative clouds. They may be from bespoke cloud service providers who only provide one service from the cloud, and that's their specialty. When you have those analysts available to you and you can keep track of all of that, you're enabling your cloud team. Without that, you're going to struggle. And so we see that as being a trend people are moving toward. Another trend that's, I think, maybe a little more fascinating that people may not be thinking about very much is the trend toward taking advantage of proximity to reduce latency. Latency, of course, is the big enemy on the network. Everybody wants to eliminate latency as much as possible. The big calling card for 5G is the end of latency. I'll believe it when I really see it. But proximity can be used as a hedge against latency. I'll tell you what I mean. There is a provider, a new cloud provider, and what they're providing from the cloud are complete desktops. So you can actually subscribe to a desktop from this service, and they'll deliver it to your device. Now, for those of you who think, he's talking about VDI, you're right. I am definitely talking about a virtual infrastructure, a virtual device infrastructure. However, this is a service with a difference. For one, it's being run on Azure, Amazon, Google. It's being run on the hyperscalers. This company didn't build its own small cloud infrastructure to deliver VDI. They're taking advantage of the incredible resilience and the incredible reach of the hyperscalers. And they're doing the VDI for you. You never see it. The people's big complaint about VDI, it's so complex, so difficult to manage. Now, they're offering VDI as a cloud service itself. And they're offering it on every cloud you use, so you get to pick and choose. In some respects, though, the cloud actually may get to pick you. Let me explain what I mean. Looking at this Mercator map, look at the far left. You can see that some of the data centers, this is a map of Microsoft's data centers. They have 200 of them deployed all over, more than that now. There's a data center in California, in Los Angeles, let's say. And there are users connected to that and using that. They're nearby. If you go to the far right of the map, we see down under, there's Australia. and they have data centers there as well. If your organization, if your enterprise has users, let's say you have 10,000 users, and they're distributed all over the planet, you can actually standardize on a platform that delivers desktops to all of them, and their workload, their desktop, is located at the hyperscaler data center nearest to them. So if the user is in Los Angeles, is in a Los Angeles data center, maybe Azure, maybe Amazon, maybe Google. If your user is down in Sydney or Brisbane, their workload is located in the data center nearest them. Now, it's not just the distance. I mean, electrons are electrons. They travel at an insane speed, speed of light. But you also have hops involved from router to router to router, given the nature of the internet. There are fewer hops between an office in Los Angeles and a data center in Los Angeles than there are between an office in Los Angeles and a data center down there in Sydney. So you do get a significant reduction in latency. It's more responsive. It's faster. Now, this obviously is not going to be relegated to just one cloud provider. More and more cloud providers are going to seize upon this, or already seizing upon it. And you're going to see more and more messaging coming out from them about how your workload will be located in the data center nearest to you so that you get minimal latency and you get as close to an on-prem performance as you possibly can. This is just beginning, but I believe that it'll become more of a trend in 2022. And then as we go beyond 2022, you're going to see it start to pick up. Exciting. Exciting because it means that all of the hyperscalers, certainly, and even all of the alternative clouds, become more of a fabric that we can take advantage of in more and more creative ways. Wanted to talk just a little bit about automation and orchestration. Obviously, in the cloud native environment, Kubernetes is the orchestrator for the containers, making sure they go where they're supposed to go and when you have millions of containers moving, that's necessary. Automation, however, is much more of a choice. It's something you can do. You can automate processes. You may not. One of the reasons a lot of people are choosing to automate processes is to allow for rapid scalability, most often to take advantage of opportunity. When an event occurs that your company can take advantage of, but to do so, you need to scale up to a lot more users or a lot more applications or a lot more functionality. The fact that your scalability is automated, it reduces your time to market. And so you have a greater opportunity to get to the opportunity faster. Of course, automation gives you more flexibility. You don't have to pay attention to the steps involved in certain processes. You can move around fast. And of course, you have to also talk about agility. The more you have automated, the easier it is for you to change directions and switch to a different approach to doing things. And so automation is becoming more and more prevalent with every passing day, and it has been for a long time. Some people are using orchestration, and more often they're using automation to level workloads so that workloads that are not used frequently are relegated to lower cost, lower performance storage, and frequently used data is moved to solid state storage. Now, this kind of leveling has taken place forever. Automation is being used now to make that happen in the context of multiple clouds. So we're seeing leveling becoming an important function. And then, of course, and we always talk about this, the utilization of human resources. We are moving human beings away from repetitive, menial work and on to more interesting, more motivating, and more productive, more profitable work. So you have people moving to better, more interesting work, and automation taking over the lower level work. And of course, there are some people out there who are very concerned that this means that automation will be replacing people. Well, I kind of want to assure you that that is nowhere near the case. Why do I say that? One thing that you wouldn't expect me to talk about when we're talking about trends in multi-cloud is the skills gap. The fact is that the more you use multi-cloud, the more people you need to keep track of the changes, to make sure everything's working together, you need CBOs and people working with those CBOs. To put things in context, I'll put a number up on the board. Care to guess what that number is? Most recently, in the reports that I've been tracking, that's the number of open job requisitions in the IT industry today, worldwide. We have 4 million open job requisitions waiting for people to fill them. A quarter of them are here in the United States alone. So millions of jobs. People are not being replaced by automation. Rather, the implementation of automation, orchestration, and many other functions taking place in the multi-cloud environment are occasioning the need for more people to take on more jobs. We're seeing a lot of trends change. We're seeing the trend toward 4-year education in college slowly disappear and be replaced by 6-month certification programs that enable a person to take on a job almost immediately. We're seeing that accelerate. And so the idea of alternative education to move people into place faster is a big trend in 2022. You're going to see returnees and returning veterans and people graduating from high school opting out of taking on tremendous debt for a 4-year college education and instead choosing to take a certification program that makes them eligible for one of these 4 million job opportunities. So my reason in emphasizing this is don't shy away from automation because you're afraid you're impacting people. There's plenty of work for people to do. There's more work being created all the time. And it's part of the multi-cloud environment. Making more opportunity for more people is a wonderful trend in multi-cloud. Which brings us to the produce section. The produce section, yes, it's lovely. We're in the produce section right now. Aren't those vegetables beautiful? We're in the produce section right now because I wanted to talk about the word organic. Organic. Organic, those of you who go back to the early days of networking like I do, will remember people throwing cables around the perimeter of a room and then drilling a hole and going into the next room and growing networks organically, meaning anytime you had another computer to add to the network, you strung a cable and you connected the cable to the network interface card that you just put into that computer. And if you needed a server and some storage, you put one of those big multi-megabyte storage devices on it. Or you hung a printer off of it or other peripherals. And slowly but surely, the network got enormous, but it did so organically. And so there weren't any safeguards built in. There was no security built in. There was no management built in. It just kind of worked until it didn't. And when it didn't work, you had to go to the middle of the network and test both ways to see if the problem was to your left or right. And if it was to your left, you reconnected, went halfway back to the left, disconnected and checked to the left and right, and you reduced and you reduced and you reduced until you found the problem. That kind of troubleshooting, I mean, just recollecting it makes me shiver. But we're seeing a recurrence of that organic approach to deployment in the cloud environment. We're seeing IT departments say, we need to experiment with artificial intelligence. Let's subscribe to AI and ML from Google. No planning, no preparation, nothing. They just decide, hey, that sounds like a good idea, let's do it. You've heard people use the term cloud sprawl. That's cloud sprawl. People ordering up cloud services because they think it's a good idea. They want to try it out. Now, of course, some of those people are not in the IT department. They're out there in the manufacturing departments, marketing departments, sales departments, and that's where we get shadow IT. Because it's easy to subscribe to these services, they do. And you don't realize it until it starts to significantly impact your network. So you really don't want to grow your multi-cloud environment organically. You want to do it under control. One of the best quotes I've encountered about this is from McKinsey that a haphazard approach to digital transformation is a pathway to failure. They comment that 70% of complex, large-scale transformations fail because of poor planning. Nothing else. So the idea is, instead of just kind of ordering up a new service because you think it's a good idea, my recommendation is always start with why. It seems like I include Simon's book in every presentation I do, and there's a message in that, right? Most everything we do should start with why. Planning what we're doing rather than just kind of going out and doing it. What do you intend to accomplish? The second of Stephen Covey's 7 Habits of Highly Effective People, that second one is begin with the end in mind. And it's really good advice. Begin with the end in mind. What do you want to accomplish in ordering up these multi-cloud services? This cloud service from this vendor, this cloud service from this vendor. What will the benefit be to the business? Now, you're going to need to know that if you're going to put together a proposal and present it to the C-suite to get your funding. And if you're not responsible for the budget, or if you don't own the budget, you're going to have to go to somebody else to request budget. The first thing they're going to want to know is, what's the benefit to the business? What are we going to get out of it? So my recommendation is know that in advance. When you do your planning, start with your current state. Don't just willy-nilly say, we're going to do this, we're going to do this. Begin by taking a good hard look at where you are. Every journey has a beginning and an end. Start at the beginning for the journey. Begin with the end in mind for the planning. And at the beginning, look at everything that you currently have in your environment. What services are you getting from what clouds? What applications are you running? What workloads are you managing? What user communities are you serving on what devices? All of it. Get to know your current state intimately. Surveying every line of business, every department, anywhere where shadow IT might rear its ugly head, hit them all. The reason I say this is that the requirements of all those departments, of all those functions within the business, that's what drives your architecture in multi-cloud. That's what drives the decisions you make about where to get various and sundry different services. Remember that the cloud providers themselves will have some requirements that you may not want to accommodate. And so your planning will be altered by the requirements coming from the cloud provider themselves. And of course, every workload that's in your inventory is going to have all kinds of requirements of its own, certain capacities, processing capacity, storage capacity, bandwidth, so forth. And so look at your current state before you start planning for your future state. My hope is that this will be the biggest trend in 2022, that we're going to see more and more IT departments stop or reach out and stop others from just willingly bringing in service because they look good. And rather, they're doing some serious planning and directing the way in which their cloud environment's going to grow. Gartner predicts that by 2025, 90% of enterprises will have a multi-cloud strategy. What's interesting is that if you do a survey, there are many, many sources other than Gartner that are saying that between 91 and 94% of enterprises have a multi-cloud infrastructure today. Now, to me, that makes a lot of sense because if everything is hybrid, it's pretty easy for it to become multi-cloud if you happen to use two competing cloud vendors. It's just not that difficult. So multi-cloud is a natural element of how we do what we do, and will continue to be so. And if there's anything that I've emphasized that I hope you'll take away from this presentation, it's that a part of being successful, a major component of being successful in assembling an effective multi-cloud environment is to have people on board whose job it is to stay very familiar, intimately know Amazon, Google, Azure, and any other cloud service you might be considering. That knowledge will fuel the continuous planning for continuous improvement via continuous deployment of your clouds. With that, Chris, do we have any questions from the audience?
We do. Yeah, that was a great presentation, Howard. Way to roll with the technical difficulties like a pro. Yeah, we have time for a few questions. Let's just jump right into them. Here's the first one. Can a hybrid cloud also be a multi-cloud, or are they two different things?
Well, I think we covered that pretty well in the presentation. But if it was confusing, I mean, hybrid simply means you're using more than one. You're using private cloud and public cloud, or on-prem and one of them. And the reality is that they're all, I mean, everything is that way. Multi-cloud, basically multi-cloud says you're using two of the same kind of cloud. You're using public and public, Amazon and Azure. So it's like every square is a rectangle, but every rectangle is not square. It's that kind of thing.
Here's a question from Paul. Can you talk about the use of cloud access security brokers as if the distribution of data is agnostic?
Not in the time that we have left. Can't go through it. I mean, obviously, I'm trying to divine the reason behind the question. The distribution of data is by nature agnostic. There is no real relationship between the nature of the data and the nature of the platform on which it's traveling or on which it's stored. And so the payload, and I guess that's the real answer to this, right? Most cloud services, including CASBs, are agnostic about the payload. They don't involve them. They can't. They shouldn't. That's where you're, breaking confidentiality, is if you consider the payload. So I think the answer is, I'm not sure exactly how to answer the question, but certainly the distribution of data is by nature agnostic, and if anything suggests otherwise, I would avoid it.
Okay. Here's another audience question. What did you mean when you said data only makes money in motion?
Well, imagine that you have a storage drive, okay, and you have a terabyte of data on there. Okay, you have a terabyte of data on there. What's that worth? And the response to that has to be to who? What's it worth to me? Oh, it's worth millions to me. But I don't realize those millions until I share that data with somebody else and have them pay me for the pleasure. So for them to share that data it has to transfer from my storage device to their storage device. So the only way that I realized value, the only way that I got paid for some of the value of that data was by moving some of it to a customer. Now, that happens in a million different ways. But the fundamental concept is that if I own it and it has a value, but it doesn't make money for me until I share it. That makes sense?
Mm-hmm. Yeah. Oh, yeah. Here's another thing, just to clarify something you kind of touched on in your presentation. What makes software cloud native?
The fact that it's written using microservices in containers. Software, and again, going back to what we talked about before, software traditionally from the beginning of software, somebody sat down and wrote a bunch of code, and it was a computer program, right? And that computer program contained everything. All of the subroutines, all of the functions, all of the things that all the logic, all the Boolean algebra, it was all in that one piece of code. And that was how it was done. Made sense. Except that if a flaw developed, the whole thing went down. And that, as we develop networks, that hurts everybody. The change is that instead of having all the code exist in one big block, the code is completely disaggregated. Completely. It's granular. Each thing that code would do exists as a separate microservice that's transported inside of a container with all the resources it needs to function. And the orchestration function enables the software to run microservice after microservice to do what needs to get done. And so the only way and there are people using microservices in containers in on-prem environments. As a matter of fact, I believe we're still at a place where the majority of microservice applications are running on on-prem systems. It was a factoid that surprised me when I encountered it. But I think that's going to change quickly. If you think about it, the idea of having these little containers running around, that's just perfect for the cloud environment, where it can go from cloud data center to cloud data center to be wherever it needs to be to do whatever it needs to do at any given time. So that's why containers, it's kind of like having marbles in a maze, So you can just shake them around and they go all over the place. And then use that image except that you have something like Kubernetes orchestrating it all of it so that all the marbles go where they're supposed to. That was a weird analogy.
It works. It got the point across, I think. This next question, this might be a good topic for a future presentation. I'm not sure how much you can answer right here, but how can our end users be expected to learn how to deal with multiple clouds? They're having a hard enough time with just one.
I get that. Okay, so to answer that, I'm going to go back to the original definition of cloud computing. Now, that was given to us by the National Institute of Standards and Technology, NIST. And if anybody who's out there in our audience has not read the NIST definition of cloud computing, go out and Google it. It's a 4-page document, 4 little pages, and it is incredibly instructional in terms of understanding what we really mean when we talk about cloud. Great document. One of the things they describe within those 4 pages is the concept of a layer of abstraction that a cloud environment provides, meaning that layer of abstraction exists between the user and the underlying technology, so that the user never actually encounters the underlying technology. Now, that's a great goal, right? The user just focuses on the work they're doing. They don't care where the file is. They don't care what server it resides on. They're not mapping network drives or anything like that. They simply pick everything off of a menu, and they do their work. Given that, the definition of cloud computing absolutely extends to multi-cloud computing. That layer of abstraction keeps the user away from the underlying technology, and one of those 4 million people we need to hire is going to be taking care of making sure that it all works. That's why I don't think users are going to be impacted at all by multi-cloud.
All right. Well, it looks like that's all the questions we have time for in this first session. Thanks again, Howard. Everyone, stay tuned. We're going to take a short. Oh, I'm sorry.
Thank you.
We're going to take a short break. Oh, yeah, sorry about that. We're going to take a short break and be back at the top of the hour for our second session of the day, multi-cloud best practices heading into 2022. Take a chance to check out those resources on your console provided by Cloud Health by VMware, and we'll be right back.
Thank you, everybody.
Welcome, everyone. The event is now live. John, please take it away.
Thank you, Lauren. Hi, everyone. Welcome to the second session of today's summit, Multi-Cloud Trends to Watch in 2022. This event was organized by the hardworking folks at Redmond Magazine and Virtualization and Cloud Review, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, Cloud Health by VMware, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends in the Convergence 360 group of 1105 Media. And I'll be your moderator for the second of our three information-packed sessions. Before we get started, just a couple of quick reminders. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. This session will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our very, very best to get to all of them. Our sponsor, Cloud Health by VMware, has provided some extra resources that can be found on the right-hand side of your screen. Definitely check those out. And during the third session, one lucky attendee will be receiving an Exo Pro Blackhawk drone. It's a quadcopter with full 4K video, 3-axis gimbal, 8K image transmission, and 4 batteries that provide 43 minutes of fly time each. But you got to be here to win, so stick with us. Now let's get started with our second session, Multi-Cloud Best Practices Heading into 2022. For this session, we called on Brett Hargreaves, Cloud Practice Lead for Iridium Consulting. During his 25-year career, Mr. Hargreaves has worked as a developer, an architect, and a consultant, helping some of the world's largest companies design and build cutting-edge solutions. He's been involved in projects covering the entire solution stack, including hardware, virtualization, databases, storage, software development, and the cloud. He's also a teacher with 5 courses on Udemy, and his blog, www.bretthargreaves.com, is a must-read. He's coming to us today from his home base in the UK. You are in for an awesome session. Take it away, Brett.
Hi, hello everyone, and thanks for the introduction, John. As mentioned, my name's Brett Hargreaves, and I'm the Cloud Practice Lead for Iridium. Now, one of my roles at the moment is to help our customers migrate to and make the best use of cloud technologies to help drive their business forwards. Now, just about every one of our customers are actually multi-cloud, and sometimes they become concerned whether that's the right way forwards, or whether there's something they can do to ensure that they don't run into technical or any operational issues. The chances are you're probably multi-cloud too. And just to be clear, when we say multi-cloud, we do sometimes mean having assets in your own on-premise network, although it's known hybrid networking. There is a bit of crossover sometimes between that and multi-cloud, as in having multiple cloud vendors. So the next half hour or so, we'll be talking about some of the ideas around implementing some of the best practices in a multi-cloud environment. Before we get into that, it's worth just thinking about how some organizations might get into this situation. So first of all, this can usually either happen through design or by accident. We'll leave the design bit for now, and we'll just focus on how it happens by accident. So one of the ways this happens is that if you have lots of different teams who are building applications, those applications might organically grow, and the teams themselves might have different skill sets. So, for example, often people generally fall into either an Azure skill set or an AWS skill set or something like that. And this is usually because they're following a particular technology stack, for example, .NET and MS SQL, or PHP, Python, MySQL, and so on. And so they tend to have grown up with these specific technologies. And so the choice of their clouds is sometimes influenced by that choice of technology stack. So the common ones obviously is .NET developers and Windows people generally gravitate to Azure, and people are a bit more fair with PHP and Linux. They tend to go maybe towards AWS, although more and more to GCP as well. Now, related to this, each of the vendors have their own certification tracks, and people do tend to concentrate on one of those certification tracks or the other. Now, I know a lot of people do do the certification and that's where they try and get them across everywhere. But in my experience anyway, you often find that any kind of knowledge is, you use it or lose it, So as people start to use one technology, they get more and more focused on that. And so again, it's just another way how people end up on one platform or another. So when we have these different teams with different skill sets, we're invariably going to end up with this different tooling. Now, COVID also accelerated cloud adoption over the past couple of years, and some sources have been citing that the whole COVID things increased the velocity and accelerated cloud adoption by 10 years. And this in turn means that sometimes choices have been made to get people into the cloud, and so they've jumped on a vendor without maybe doing as much due diligence as they normally would. So that's another reason why they might have got in somewhere and got into different clouds, because different teams have just gone off in different directions. Finally, some people are actually multi-cloud for political or even regulatory reasons. In the past, I've worked for organisations who, because of the work they do, they actually have to be across vendors. And so because of that, sometimes it is actually a design choice from the start. And actually there is some benefits to using multi-cloud, and we'll look at some of those later. So the next question is, let's ask, why might people go multi-cloud, or why is it a good thing? So first of all, in my opinion, I've often thought that the choice of cloud, one vendor over another, is largely irrelevant, certainly when you're looking at the three main vendors. Most of the time, whether you choose Azure or AWS, you're not going to end up spending more than one over the other, and you're generally not backed into a corner being able to, unable to do something depending on what cloud vendor you've picked. So again, it doesn't necessarily matter. So then you might think, well, why worry about multi-cloud at all? Why not just stick with one vendor? Well, first of all, like I said, the first issue is that many organizations might have just organically gone that way. Again, because of regulatory or other reasons. And it's usually driven by, historic use and things like that. So with this in mind, we're going to be thinking about these different multi-cloud things. And if the first question is going to be, if we are multi-cloud and it doesn't really matter, should we migrate back to a single platform and just go on one cloud, or should we embrace the multi-cloud? So first of all, consolidating onto one platform can actually be quite costly, especially if applications have been built using native components such as Azure Functions or AWS Lambda functions, because the code when you build it with them is particular for those functions. So if you wanted to move from one cloud to another, you actually have to rebuild that technology, which, like I say, can be quite time-consuming. So again, so it might be that in those situations, you are better just saying, we are multi-cloud. So instead of trying to fight against it, let's embrace it and see what we can do to make our lives easier. So if we're going to go for multi-cloud, let's think about some things that we need to think about. So the first is, and the one at the top of most people's agendas, is vendor locking. They don't want to be, or they're concerned about getting stuck in one vendor. Like I said earlier, if you've written Azure Functions, it's very difficult to move over to another cloud vendor. Another is performance, and this is especially key if you've got some applications in one vendor and another application in another vendor, and they need to communicate. Something else to consider is deployment. Each vendor have their own deployment mechanisms. And again, so if you move from one to the other, you might need to rejig or retool some of those deployments. And then finally, we have security management and monitoring, which are also quite important. And again, as we go across multi-cloud, can start to become a bit more of an issue. So let's have a look at these in turn. Okay, so first of all, vendor lock-in. As I say, this tends to be one of the biggest concerns when developing solutions for the cloud. And the argument is, if we choose a cloud-native technology like, say, Azure Functions or AWS Lambda, then if we want to move them to another vendor, we have to recode it. It's not as easily to transport. So one way you can get around this issue is to actually just code stuff on traditional virtual machines. So rather than trying to use native components, you go old school and you build stuff and deploy it to a VM as you would on-prem. And this gives us complete flexibility because we know we can run a Windows or a Linux VM on any cloud or on premises. And in fact, if you're an established organization, the chances are you've probably already got a lot of apps like this, and especially if you've done a lift and shift from on-prem into cloud, you'll probably have some VMs running this stuff. But of course, it's not very cloudy, it's not very modern, and even if we try and implement, some more modern tooling to those VMs, to be able to scale them, building database with some web forms, it's still not as flexible or efficient as using native options or some of the other options we'll look at. And finally, it's also a pain. It's very difficult, or it's more difficult to deploy when you're using VMs because as part of your deployment pipelines, you've got to script out how to build those VMs. And there's a lot more that can go wrong with those compared to cloud services. And then finally, of course, if you are using VMs, you've got to maintain them, which, it's one of the reasons why a lot of people go to cloud, is so that you don't have to do all that. In fact, that's one of the biggest drivers that a lot of vendors use to drive people to use the PaaS offerings so that you don't have to do all that management. So let's have a look at some better options. The first thing we'll look at is an increasingly common way of getting around this, which is containers and Kubernetes. Now, before I get started, I'll just clear it. This isn't going to be a session just on Kubernetes and containers, so don't worry about that. I know there's a lot of that goes on, but it is a valid option, and as I say, it's a very popular option. Just in case there is anyone who doesn't know, or just to have a bit of a refresh as to why containers and Kubernetes is a good idea, we'll just have a quick run through what it's all about. So, containers allow you to define complete environments, or the environments that run your applications in a portable manner. So again, if we think about a virtual machine tends to be a full-blown instance with an operating system and then the application installed within it. Whereas a container is an isolated environment and you run multiple of them on top of a virtual machine or on top of a single OS. So this means that the OS, the container itself doesn't contain the full-blown OS. That's part of the engine that runs the containerization. And instead, we just have all the dependencies required to run that application. Now, this in effect means we have much greater density, which means you can run far more containers on the same underlying hardware than you would if you just had a pure virtual machine. Another aspect of containers is that you can also define them in code by detailing the dependencies and requirements for the application to run. And the point of that is that you'll be able to define that environment, what it looks like purely in code, which can then be put in source control and can be easily deployed to anywhere that's got a containerization environment there to take it, safe in the knowledge that that environment you deploy it to is going to be as you defined it. It's completely portable, whether you're going from one vendor to another or to on-premises. Now, the most common container engine at the moment is Docker, and all the cloud vendors, or most of the main cloud vendors, do all support Docker environments. And of course, there's also an option you can even build your own relatively easily. So as I say, the cloud providers, Azure has, for example, Azure for web apps, or Azure web apps for containers, or Azure container instances. AWS has Elastic Container Service. And all these, the vendor worries about the underlying platform, so they just provide you with a Docker platform that you can just deploy your containers to without having to worry about patching and maintenance. And it's much easier then to be able to deploy your applications from one vendor to another and without making any modifications to your code whatsoever. Now, as containers provide much greater density now, so we have a lot more of them consuming less resources, it enables the use of a pattern called microservices. So microservices tend to be discrete services that generally perform specific tasks, and are deployed as self-contained apps. You can then scale those individual microservices dynamically in response to demand. And this paradigm of software design is incredibly powerful, but it does lead to an issue. And that is that if you have lots of containers running lots of different individual microservices, how do you manage the up and down state of those containers? And how do you do the automatic scaling? So the answer is orchestration. And the most popular orchestration tool at the moment is Kubernetes. So Kubernetes kind of sits in the middle of the platform as a service and the infrastructure as a service world. It actually runs on virtual machines under the hood. And in fact, one option if you want to have Kubernetes clusters is to actually just build it yourself using virtual machines and putting Kubernetes over the top. However, again, the main vendors all now offer Kubernetes as a service. So again, for example, in Azure, we've got Azure Kubernetes, AKS, and Amazon has Elastic Kubernetes Services, or EKS. Now, although it's a service, as I say, it's kind of half and half platform as a service and infrastructure as a service. The management layer, the bit of the Kubernetes that does all that management and the really clever stuff, that's generally the PaaS. That's generally the bit that the vendor manages it for you, and you don't need to worry as much about that. But the actual virtual machines themselves that run the containers, and they are still on VMs. And when you spin these up in any of the environments, you can generally go and see the VMs there. And this means that there is still a certain amount of management and patching that you still need to do yourself on those underlying VMs. Again, it's all made a lot easier, but it still needs to be thought about. So Kubernetes is very, very powerful, especially in this in what we're trying to do with multi-cloud. And it has a lot of benefits, especially for microservice-based solutions. Because as well as being able to orchestrate creating and destroying new instances of your containers in response to demand, it also monitors for failed containers and replaces them with healthy ones, and allows for easy upgrades to your old code by replacing old versions with new versions in a much more controlled manner. The other big benefit is that you can fully define those orchestration rules. So again, as we talked about with containers, how you can define what the container needs to look like in code, you can do the same with Kubernetes clusters. And you can even set dependencies between one service and another. So in short, the combination of Kubernetes with containerization gives you the ability to build your application completely agnostic of the underlying hosting vendor, be it AWS, Azure, on-premises, or wherever. Therefore, that tends to be one of the biggest arguments for using Kubernetes, and you don't need to worry about that vendor lock-in. As long as you've got a Kubernetes cluster on your source environment, your developers can just build a solution on the stack of their choice and create the deployment pipelines and point them at that cluster. Now, Kubernetes is that popular and that powerful that the cloud vendors themselves are embracing this tactic for expanding their own management offerings, and they're actually allowing you to hook into Kubernetes clusters either on-premises or in the clouds and manage them from a central location. So, for example, I'll go for Microsoft ones because a lot of my experience tends to be more on the Microsoft side, and AWS have GCP have similar things. So with Azure Arc, it allows you to build a Kubernetes cluster, like I say, in any cloud or on-prem. You install some Arc agents on those clusters, and then they appear in your Azure console as though they were part of your Azure platform, and they can be fully managed then from that central location. Now, what is interesting is that specifically with Azure Arc, you can actually now deploy Azure native cloud services to those Kubernetes clusters that are running on-premise or wherever they are. So once you've connected this external Kubernetes cluster into Arc and installed the extensions, you can then go and run Azure Web Apps on them, Logic Apps, Azure Functions, API Gateway, and Azure Event Grid. So with these extensions installed, you just deploy your existing code that you built for any cloud native, any Azure specific services, onto that Kubernetes cluster, regardless of where it actually is. And the Azure portal simply sees these services just like any other location, and you can monitor and manage them as though they were running natively in Azure. So again, the whole point is that all these vendors are getting onto this Kubernetes bandwagon and really looking at how they can leverage it to give these consistent experiences across clouds without you needing to worry about the vendor lock-in. Now, one of the big advantages of the Azure Arc one is that actually your development team don't need to subscribe to the normal Kubernetes development patterns, because using Kubernetes, because it's a different paradigm, it is a bit different to the normal pattern. So, for example, if you are an Azure developer and you're just used to building Azure functions or web APIs, you're used to building things in a certain way and building your deployment clusters to work in that way. And if you go to the full normal Kubernetes deployment model, there's a lot more involved, there's a lot more to do. So the Azure Arc kind of, again, takes that all away from you and just makes it a lot easier. Personally, I find a lot of the time the choice of whether to choose Kubernetes or anything tends to come down to the complexity of what you're building and the skills on the team. If your team doesn't have Kubernetes skills, switching to Kubernetes can be a bit difficult, a lot of retraining and a lot of learning to go along. I also personally feel that sometimes stating the best way to leverage multi-cloud is to remove and reduce vendor lock-in can sometimes be a bit misleading. But again, it all depends on what it is that you're trying to achieve. The biggest danger I see with Kubernetes, and it happens a lot with people who have expended a lot of time and effort into using Kubernetes clusters, is they start to follow the adage, if the only tool you have is a hammer, you tend to see every problem as a nail. And so, although I'm not saying don't use Kubernetes, I'm just saying it is just one option, and we just need to be aware of that when you're choosing it. So with that out of the way, let's have a look at some of the other options we can use when going for multi-cloud. So I used to be a software developer, and I used to wrap myself in knots trying to predict what potential problems my code could introduce in the future. So I'd worry about the choice of one database over another might cause issues later on. And I'm sure I wasn't on my own. And in fact, one of the big problems with building solutions with a full upfront design is that when you finally present to a customer, it might not actually be what you want. So there's always been this worry. And so that's how the Agile came about. And of course, although cloud is not just about software development, the same tenets that we use in software development, i.e. that agile way of doing things, can quite easily be applied to cloud. So if we're taking an agile approach to our technology as we build our applications and our infrastructure, we don't necessarily need to worry as much about AWS or Azure. We need to try and think of ways of building the solutions that they can be a bit more dynamic. So one of the things we can do about this is when we are building our applications and designing and architecting our applications, is try to build them in a bit more of a modular design, thinking about what might happen if we need to be able to move vendors. And we'll look at a bit of a typical example of what we can do. So when designing solutions that require a database, traditionally we need to decide our database early on. Now this is because different databases require different ways of interacting with them. You know, even between Microsoft SQL and MySQL, the commands can be very different. It's subtle, but still enough to break things if you were to move databases. So again, what we need to do is find ways of factoring this ability to swap things in and out quite quickly, because we might want to move from MS Azure SQL to a NoSQL database or a completely different vendor's database. So we do this by building our applications in a modular fashion. And the first thing we do is we start to build our applications using these abstraction layers. And an abstraction layer is a way of separating out the bit of code that's responsible for a certain paradigm. It's very similar to microservices, and in fact, microservices in many arguments is a bigger even extension of this. So the idea is, rather than say a user interface that's making calls direct to a database, instead we make the calls to an abstraction layer, and that abstraction layer is then responsible for calling the database. So this solution pattern as a whole is often known as dependency inversion, and it basically means that any of our code units need to be able to be used independently from each other and can be easily swapped in and out. Now, many development languages use interfaces and dependency injection to achieve this. An interface is where you state what actions can be performed, like get all product, get product by ID, and the UI would be told to use one of those interfaces. But then the actual implementation, our abstraction layer, would then be injected into the runtime stack. And as long as our abstraction layer implements all the action states in our interface, we can swap in and out the new implementations with new databases and things. So in terms of cloud, what this is basically meaning is if we build things in these layered approaches, it gives us more flexibility if we do want to move between vendors, because it reduces the amount of code that we might need to change. So again, if we're moving just from one cloud to another, and it means we need to change the database, underlying database that it's running, it's just the data layer that we need to worry about. The rest of the code might quite happily easily sit on the vendor's cloud and on their native options. Of course, that's only addressing one specific area about databases, and we have to think this across the stack really. So again, if we take things like some of the serverless options, which is a big one which causes people to worry about vendor lock-in, for example, is that, again, as I said, if you build code for an Azure function, you can't just pick up that code and drop it onto an AWS Lambda function. That's not going to work. But again, what you can do using this modular approach is you can build your common code blocks, the bits that have all your complex logic in. And then you can wrap them in a layer that will then interface with the native technology, so AWS Lambda or Azure Functions. And this, again, is just another way we can more easily move between vendors without as much rework on our code. Of course, there's a big difference between applications that only rely on, a couple of cloud-native components in a couple of areas and highly complex solutions that use lots of different areas. So again, it's just important to reiterate, it's just one potential way to reduce vendor lock-in, but it isn't entirely dependent on how complex your solution is that you're building for. So another area that's quite important to think about when going multi-cloud is that of performance. Now, I'm specifically talking about performance when you might have a solution in one vendor and a solution in the other, and the two need to communicate with each other, because that's when you can start to run into some performance difficulties. So as cloud solutions proliferate, you'll have these solutions in different vendors, and you might even have them across regions and countries. And so then we need to think about how, these patterns, how we can connect them together and reduce the amount of traffic that we need to flow between them. Now, again, like earlier, a lot of this can be addressed just with good application design. And it really comes down to two things. The first is where the data is and how we connect to it. And secondly is how it actually gets consumed. So we'll take the first bit first. So if you think about a typical solution where you'd have a user interface and a back-end storage mechanism, a really simple app might have a UI that talks directly to the database. Now, one of the problems is thinking about what traffic then gets sent from the back-end to the front-end. So there's a couple of aspects to this. The first is thinking about the database queries itself. So if you've got, say, 100,000 records and you want 100 records into your UI, you can either do the query at the database to send just a subset of records up, or you can get all the records sent up and do the filtering at the UI. Now, that might sound like a daft thing to do, but I have seen it done, especially more modern UIs, developers trying to be a bit clever with them to give it a more clever user interface. But when you're going across regions and spanning vendors, it becomes more important to really think about this and really lock down the amount of information you're sending back between those components as much as possible. And so and so things like this just come down to simple design choices, such as when you're talking to a database, have a layer in between, such as an API layer that can maybe do a lot of that high-speed connection that it needs and apply a lot more logic that then gets sent up to your consumers. And of course, we can also implement caching and things like that. Again, it's all about reducing the amount of traffic that's going between them and keeping it to a minimum. When dealing specifically with solutions in the cloud, it also needs to think about traffic costs, because it's not just performance. A lot of cloud vendors will charge you more for traffic going out. Now, generally, it's not a problem if it's on small amounts of traffic, but if you've got terabytes and terabytes of traffic going out, then it's going to, those traffic costs will start to build up. Another design pattern that can help us is that how we do that communications to the database from a point of view of how we connect them. So the traditional way, like I said, would be that an application would connect directly to a database via an API, and when it makes call, it sits there and waits for a response to come back. Now, when you're going across vendors and things like that, because you've got these network areas in the way, that can again, cause these issues, because if there's an interruption to the connection, it can cause all sorts of problems. So a pattern we can use to get around this is the queuing mechanism. So with a queue, one side of the application has some data that it needs acting on it, and it writes the information to a queue. Another process at the back end, often called a consumer, subscriber, or worker, will monitor that queue and do something. And then when it sees the data go into the queue, it will pick out the data and do something with it. And then it might write back to another queue for the UI to be notified, or the other application to be notified that it's been processed. So the point of these queues is to remove that need for one app to wait for another app. In client-side scenarios, this basically means returns control to the user while everything's happening in the background. The other thing that queuing does is it also allows for you to set up multiple consumers to work on the queue. So you don't just have to have that, one front end to one back end. You can have one front end to two back end workers or more. And this significantly increases your ability to scale. Again, it all depends on the kind of workload you're using. But all the major cloud vendors do offer their own queuing mechanisms. And again, there's also a lot of third-party options out there that, again, you can install on premises and so on. So one of the many benefits of cloud technologies is that your entire environments can be defined in code. And we touched on this a bit when we talked about Docker, but actually you can do this with any infrastructure code within the cloud. And this is called infrastructure as code, or IAC. And in fact, when you do any kind of deployments, if you go to the cloud portal, the vendor's portal, and you start telling it to create things, in the background, it's actually creating those things in code, in templates, and then sending to the back-end APIs to manage the deployment. And ideally, your own solution should be defined in code themselves, and then you would use them as part of the deployment pipeline so that you can more easily push those deployments in a repeatable manner. However, when we're thinking about a multi-cloud environment, this actually causes us a problem. And that's because each cloud vendor has their own format for what these deployment codes look like. Azure uses Azure Resource Manager templates or ARM templates. AWS uses CloudFormation. And any code you've written in ARM can't then be used to deploy components to AWS and vice versa. Now, there's a number of ways around this problem, and again, it largely depends on the type of team you have or your end goals. So the first option is to simply live with it. So if your cloud teams are already split between vendors, So, for example, if you had an Azure engineering team and a separate AWS engineering team, then it might just make sense to develop the infrastructure code separately. After all, each vendor doesn't have its own components, so the code would be different anyway. And so then in those cases, it might only become an issue when you're deploying common elements such as virtual machines. Other than that, you might not gain too much. However, sometimes that's not the case. Sometimes you just have one team. And so another option is to use an intermediary or common language that then gets translated for you to a normal cloud formation template. And there's a number of such languages available to do this. And the power of them is that the skills are then easily transferable between clouds. So once you've learned how to use this intermediary code, and you know that language, you no longer need to worry about the individual vendor's code. You just build it in the intermediary, push it to the transpiler, and it worries about how to translate it accordingly. That said, each vendor still has its own components, so even though it's a common language, you still need to understand some of the nuances of each cloud vendor because obviously they're each slightly different. So the one issue with this intermediary language is that you're reliant on the team or organization that builds that language and maintains it to ensure that they're up to date with the different cloud vendors. So if one of the cloud vendors brings out a new component, a new offering, well, you can't then go and deploy that using an intermediary language until that intermediary language has been updated to support that new component. But of course, the biggest benefits of having this intermediary language is that you only have one team and one language to learn, but that the fact that you might always be slightly behind is just something that you need to bear in mind. So the final area I wanted to cover was management and security and monitoring, and we'll lump that together. So once we've got everything deployed and running, we need a way to monitor our services for performance, for issues, and for security. Now, ideally, we'd want a single pane of glass to do this. That is, we want a single location where we can view the information across all our vendors. And much like the problem with the infrastructure of code that we were just talking about, again, we've essentially got two options. We can either go for a third-party service that will integrate that across multiple vendors for us, or we can leverage the native cloud-owned management monitoring tools because actually the vendor-native ones generally allow you to do some kind of integration with other clouds. Now, going for a third-party might seem the obvious choice. But of course, employing a third-party product does come with additional costs. There's the license costs of the platform itself. However, we do also, again, need to consider about the traffic costs. In order to monitor your platforms, you've got to be continually collecting logs and transporting them from your cloud vendor to the third-party platform. And that is going to incur additional traffic costs out of the platform. Now, the actual costs for traffic are usually quite low, generally around 10 cents per gigabyte, depending on the vendor. However, when you're continually streaming these logs, those gigabytes can really add up over the month. And so you just need to be aware and monitor the kind of traffic you're receiving and keep an eye on it. You also need to consider the locations of where you're sending those logs to. Again, if you're going to a third-party vendor, generally they don't have as many geographies, and so you have to be careful that your logs aren't going from a location that is compliant with your regulations into a location that's not compliant. So, for example, if all your logs, if you're in Europe and all your logs are going to America and vice versa, for compliance and regulatory reasons, that not be satisfactory. So again, the other option is you can use the vendor's own native cloud monitoring solutions and connect them into the cloud vendors. And again, most cloud vendors monitoring solutions do offer this, to varying different degrees. With that in mind, I mean, as an example one is Azure, again, have Azure Arc, which, as we've already mentioned, allows you to connect Kubernetes clusters that are hosted in the cloud providers and then deploy your application to them. And just by connecting them to something like Arc means you can then start to leverage Azure logging and monitoring services on those clusters. So you start to effectively create that single pane of glass. To extend that further, Azure Defender, which is their monitoring solution, now has AWS and GCP connectors that allow you to plug directly into the cloud capabilities, whether they're using Azure Arc or not, Kubernetes clusters or not. And using this service, you can assess things like your GCP and AWS resources according to security recommendations. So, for example, CIS, PCI, DSS, and so on. It also allows you to hook into containers and extend, again, the Azure Defender's threat detection capabilities to those containers or to your EKS clusters. And of course, you can also connect up to standard VMs, so Windows and Linux VMs. Again, running it as vendors, we can bring all those things together. So we've looked at quite a few options there. So I'll just go through a quick summary. I think the first thing is that actually being multi-cloud can actually bring a lot of benefits, and it's not something we need to be afraid of. It's just something we need to be, if we're going to do it, need to be aware of it and just give the correct thought to our solutions when we're designing them. So, as I say, one of the things we need to think about is the communications between the services. Don't transfer more data than you absolutely need to. Secondly, you could look at using microservices and Kubernetes clusters and use modular code. Again, just think about how you can design your solutions and build them in this modular fashion so that if you do need to move between vendors, it makes it easy to be able to pick up and drop in so that you've either got no code changes to make or at least minimal code changes to make. Kubernetes is great, but only if you've got the skills and it makes sense. It's not always the right answer, but it is a very powerful tool. We need to think about how your DevOps teams are going to build and deploy their infrastructure templates. And again, do you split your teams and have them focused on one vendor or another, or do you go for an intermediary language and have a single team that covers both clouds? And then finally, as we've just said, we need to think about monitoring. And it's about whether you want that single pane of glass, but you've always got to consider the traffic costs as you start shipping logs out of any one vendor either to another vendor or to a third party. So that's the end of this presentation. I think we're now ready for a Q&A.
Thanks, Brett. Okay, let's get to some questions for our attendees. I want to remind everybody that you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Okay, so we've got a question here from Donald, and he's asking, is the Apple iCloud Keychain Password Manager a good solution for password management for security with cloud services?
Ooh, I would say it's better than nothing. However, if you're working in an enterprise, I think there are better enterprise options, scale options out there for password management.
Gotcha. Okay, Kishana's asking, is it better to find people with skill sets in multiple clouds? I think she means or hire multiple people with specific skill sets. That makes sense?
Yeah, so I think a lot depends on the existing skills you have in your team and the complexity of the solution and who's going to be supporting it going forwards. And if your team's already skilled in a particular area, then Sorry, I've got myself a bit lost there. Yeah, so sorry. So, like I said, it depends on the skills you have in the team. So I've actually found that both models are used, and it depends on the size of your team. And one of the things that you do find is cloud skills are transferable. So generally, if you know Azure already and you want to move to AWS, it's a much easier thing to pick up those skills if you've already got them than if you're coming from nothing. So they are fairly transferable. What I would say is, even though engineers can generally flip between them, like I say, skills are one of those things you either have to use them or lose them. So it's all very well if you're stuck on a project doing just Azure stuff for 6 months, for example. If you're then switched to an AWS project, although it's possible to do, there's going to be a bit of time while you get back up to speed generally.
Okay. This is from Anna. She's wondering, how do you decide when to invest the time implementing something like Kubernetes versus the other options you mentioned?
So again, it comes down to the skills in your team and the solution. If you've already got the Kubernetes skills in there, then obviously it does make more sense because, especially with things like Kubernetes, once you've got your mindset into that, it is a very powerful and tool to use and gives you a lot of flexibility. If you don't have any of those skills already, then you need to start looking at what the application actually is. If it's a relatively simple application, if it's just a web front end with an API, talk to a database, I'd argue not to bother. If it's going to be a complex application that's going to have lots of moving parts in it with lots of interdependencies, then that's when you need to start maybe thinking about Kubernetes, because that's where it starts to excel about, orchestrating and managing these highly complex solutions.
Okay. So here's one from Keys. She's wondering, so you haven't mentioned vendors hosting locations. Do you see this as a potential issue?
Well, generally, most vendors offer a lot of the same locations, and they are all expanding all the time. What is worth considering sometimes is how many locations within any particular region a vendor has. So, for example, I'm in the UK, and in the UK, AWS have only one region in London, whereas Microsoft have two regions. There's one in London and one in Cardiff. Now, within those regions, you have multiple data centers within that region, and that's called zonal resilience. But if you actually bothered about having multi-region resilience, and for regulatory reasons you've got to stay in the same, country, then it becomes a problem. Then it becomes an issue that you need to consider. But I'd say that's the only real use case, and certainly in places like in American things, it's not an issue. I think it's more the European one.
Fascinating. Okay, here's one from Dupree who's wondering, are there any licensing considerations when choosing a vendor?
The only one I tend to come across is with the Microsoft one. So obviously with Microsoft you can get these enterprise license agreements which cover you for X number of OSs or SQL or whatever it might be. Now, when going to Azure, if there are certain technologies they offer that allow you to have hybrid licensing, which takes into account your existing enterprise license agreement, and on the component cost that can make a big difference. When you go to things like GCP and AWS, it's a bit more limited. I know AWS does hybrid licensing for the OSs, but not necessarily for the SQL. And I have seen that sometimes where people have had to switch to Microsoft Azure simply because they've got a big investment in that enterprise agreement.
Mm-hmm. Fascinating. We've got time for one more question. This is from Anna here, who wants to know, do you foresee data protection issues with using multi-cloud?
So I mean, the top vendors all provide encryption at rest and encryption between services by default now. I mean, obviously, it's very, very important to them. The last thing any of the vendors want is some sort of breach due to, data protection issue. But at the end of the day, whenever you're transferring data between systems, especially if you're going across vendors, it can be a concern because you need to think about what route that traffic is going to take. Now, the endpoints are always HTTPS, of course, so you could argue that it's secure anyway. But the other option, of course, is to create VPNs, and all the vendors have their own native VPN solutions, and you can connect them up, and that gives you an extra layer of security. But also, the other thing I always say is just always minimize sending of data anyway, but certainly highly sensitive data. If you are sending some of the highly sensitive data, think about if you actually have to send it. Sometimes you can just send some of the non-sensitive stuff or mask it or something, but I'd always try and keep it to a minimum.
Brett, thank you so much for a great presentation. Looks like that's all the questions we have time for. Thanks again to Brett Hargreaves for this awesome session, and to our sponsor, Cloud Health by VMware, for making it possible. We're going to take a short break now, but we'll be back at the top of the hour for our third session, Hottest Third-Party Solutions, which will be moderated by my colleague, the awesome Olivia Urzar. And now would be a great time to check out those extra resources on your console, which were provided by Cloud Health by VMware. And remember, during the next session, we'll be giving away an Exo Pro Blackhawk drone. But you must be present to win, so stay tuned. Back in a few.
Welcome, everyone. The event is now live. Olivia, please take it away.
Hi, everyone. My name is Olivia Yerzart, and I'm so happy to welcome you back to our third and final session of the day. Captivating insights on public cloud management and security. Some quick notes before we get started. First off, we want to thank you for attending. Thanks for joining us today. But be sure to stick around towards the end, not only because you'll be eligible to win an EXO Pro Blackhawk drone in our random drawing, but also because as you leave, you'll be asked to take a short survey with your opinions of this event. Please share your honest opinions. I promise our editors really do read each and every comment, and it shapes the future of our events. And speaking of future events, I want to take a moment to really thank our sponsor, Cloud Health by VMware today. They're sponsoring this event because they believe in this community and want to support events like these. So please, please, please show your support and appreciation by downloading those great resources that are in your console and visiting their site and contacting them for a demo. It's through their underwriting of these events that we can bring more summits like this in the future. So huge, huge, huge thank you to Cloud Health by VMware. And thank you to our speakers for joining us today, and of course the moderators and everyone for being a part of today's event. But with that, I am so thrilled to welcome our speakers for today. I'm pleased to be joined. We have two speakers, and then we're also spoiled to have another one join us for our Q&A at the end. So first, our speakers for today's session will be Nikhil, Group Manager, Product Marketing, Cloud Security for Cloud Health by VMware. And we're also joined with Marie Burke, Director of Product Marketing at Cloud Health. And finally, Amber Gregorio is going to be joining us for the Q&A. So stick around, and as they are chatting, please go ahead and pop your questions in that Q&A box so that we can get to those towards the end for that live audience Q&A. And with that, let's take it away.
So starting with the macro level business trends that we're seeing, I'm not expecting this to be a surprise to anyone. I think many companies are having a renewed focus on being good global citizens of the world. And so this slide here is based on the United Nations Sustainable Development Goals. And there are 17 of them. And in preparation for this webinar, I actually wasn't aware that there were 17 different Sustainable Development Goals. Nikhil, did you know that there were 17 Sustainable Development Goals?
No, I had no idea, but yeah, I read about those when I went through this report. Yeah.
Yeah, it's really impressive how much content and effort and research has gone into the development of these goals. And they really expand a wide range of areas from protecting the planet, ending poverty, keeping the water supply clean, all those various items that are really important for the future success of all of us just as a civilization and as a community. So really, you're seeing a renewed focus on all of these efforts. Given the pandemic and work from home, there's been a lot of cascading impacts throughout the world. And so the focus on sustainability is becoming really important for all businesses. But there's one trend that we're seeing particularly, and that's around carbon neutrality and carbon emissions. And so VMware as a company has actually been very vocal about their goals for carbon neutrality. They publish a VMware 2030 agenda that goes into great detail on this. But as you can see here, building sustainability into our data centers, our clouds, our technology is becoming increasingly important. And so many companies are interested in measuring the carbon footprint that they're putting out there, as well as reducing those emissions as well. And so several, native public cloud providers, several different vendors in the market are releasing dashboards and reporting capabilities specifically in this area, which is really quite interesting. And these are things that have been coming up in trade shows, and we heard it at VMworld this past fall as well. And so these are just recurring themes that we're expecting to carry on throughout 2022. But now that we covered the macro level business trends, I would love to dive more deeply into the multi-cloud trends, which is really a key area for this presentation. And so to start, I'm wondering if this chart surprises anyone, and please feel free to weigh in the Q&A chat window. But we are seeing an increased trend towards multi-cloud adoption, and so this statistic here is based on our global maturity assessment. And this is an assessment that is available on the Cloud Health website. And so any prospects, customers, partners can take this assessment. So it's really giving a broad view and is not solely focused on our customer base. But we're asking, what is the trend in the strategy for each of these organizations that participate in this assessment? And so in some cases, it's that the organization doesn't have a strategy, or perhaps the person taking the assessment was unfamiliar with the company's strategy. And so in that case, that lends more to a collaboration conversation that the users can have within their own organization, because if they're not familiar with their organization's cloud strategy, that's an open door there for a new conversation. And then we're all, of course, still seeing many companies, roughly 20%, that are still on-prem and looking to migrate to the cloud. And in some cases, companies will never fully migrate to the cloud. There's always going to be some workloads or some business case that may need to keep certain aspects of the business in an on-premises capacity. And so we're still seeing that continued movement on that side as well. And then there's the use of a single public cloud, such as Azure, or a private cloud, perhaps like VMware Cloud on AWS. And so many organizations are starting to move into the cloud space as well. And then we're seeing the bulk of the respondents here focusing on multiple clouds. And so this could be a combination of public, private, hybrid, local, and shared clouds. And so really seeing an increased trend towards this space, making up 47% of the statistics here. And so Nikhil, my question to you is, what are you seeing on the security front? Are you seeing the use of multiple clouds? Are you seeing primarily a single cloud taking the forefront? What are your thoughts there?
It's very similar. We're seeing, as you can see the trends here, right? We're seeing a lot of organizations use multiple clouds, and it's not necessarily a security strategy, it's the company strategy. Often in our customer organizations, what we see is sometimes finance has a mandate, whether it's to prevent vendor lock-in or to maximize the discounts that they're getting from different providers. They might be using different cloud providers for different reasons. Sometimes organizations, also IT organizations, have different strategy. They have ELAs, enterprise agreements with the cloud providers. So they may want to maximize what they're getting from those cloud provider and relationships. But the interesting piece is at the macro level, while the organizations are multi-cloud, at the micro level, individual teams are single cloud provider. If I'm building my application, I'm still in a single cloud provider and care about that ecosystem the most. So it's very interesting that as an organization, we need to figure out a multi-cloud strategy, but at the same time, we can't ignore the depth that of governance and management and security needs we need to have in a single cloud provider, because when we are engaging with, let's say, a single application tier or DevOps teams, those matter a lot. Generally, it's very similar to what we see in management space compared to security.
Yeah. Definitely. Yeah, and that's an excellent point. We really need organizations, and as a best practice, to establish, consistent operating procedures, consistent tagging practices, for example, security policies to be adhered to, compliance frameworks, really getting everyone in the organization on the same page, because we're also seeing that some organizations aren't multi-cloud intentionally per se. They may become multi-cloud due to mergers and acquisitions, for example. An enterprise could be predominantly focused on Amazon Web Services and then acquire a smaller organization that may be running on Azure. And so just being able to work across multiple clouds becomes a new challenge for those organizations who weren't necessarily prepared to be a multi-cloud company. And so kind of continuing off of this theme, there's a list here of popular cloud combinations. And I do just want to make a general disclaimer that respondents who took this assessment did not have an endless list of possibilities for clouds to choose from. So for example, Alibaba Cloud, which is really focused in a specific region, was left off of this assessment. And so we focused primarily on what we would consider kind of the leading cloud providers in the space, so Amazon, Azure, Google, as well as VMware Clouds. And so that's really the focus for this assessment, but definitely would love to hear in the Q&A window if anyone is using Alibaba Cloud or IBM or any of the other clouds in the market, because that's of particular interest to us. And so looking at this slide here, you may or may not be surprised by the results. AWS is exceedingly the leader in this space, and given that they were really the first cloud to the market and the first innovator in many areas, such as reserved instances and savings plans and things of that nature, at least on the cost side from my perspective, it's not a surprise to see that they're taking the leadership position here. One thing on this that does interest me, though, is Oracle Cloud has a stronger presence than Google Cloud. And so I actually would have expected the opposite here. And so, Google has made some great innovations specifically in the Kubernetes space, which Nikhil will talk about in just a few moments here. And so just wondering, Nikhil, what your thoughts are on the placement of these various clouds and if this is aligning to what you're seeing in the security space as the front runners in each of these areas as well.
Yeah, so, it varies depending on the security domain, right? So when it comes to, let's say, we'll talk about some of these things later in the conversation. When it comes to configuration, you really need a multi-cloud strategy. What's also interesting is the introduction of Kubernetes is kind of introducing connection between different cloud providers. So you need to have a multi-cloud strategy there as well. But there are areas where a lot of these cloud providers are very unique. For example, the IAM security model, which we'll touch upon later, are very, very distinct across each cloud provider. Some of these cloud providers were early into the market and they provide a lot more flexibility, but others have had the opportunity to learn from them. So the key point here is, like, as you can see, as you mentioned, right, an organization can have a multi-cloud strategy sometimes by accident. So at a governance level, it's important to have that view and be able to figure out how you're going to support different teams who have different security needs in each of these environments. That becomes very, very critical, especially for the information security departments.
Yes, exactly. And, different clouds, as you mentioned, have different strengths and weaknesses. And so, there's multitudes of research out there where you can learn about the strengths of each of these different offerings. But, Azure, for example, really does well in the platform as a service component area. And so Google may have strengths in Kubernetes. Amazon was the first innovator to the space. And so it's going to be really interesting to see as these new clouds come to the market and these emerging clouds, so to speak, really take a foothold and a presence to see how this chart may change in future years. And with that, as I mentioned, Google being a strong cloud in the Kubernetes space, I would love to hand things over to Nikhil to talk more about Kubernetes adoption.
Yeah, so in the Kubernetes space, it should not be a surprise to anybody here that we're seeing strong momentum. If you look at the data from 3 years back, a lot of this information comes from a State of Kubernetes survey that VMware runs year after year. So in 2018, we saw that only 30% organizations were running Kubernetes in production, and that number has grown steadily over time. Last year, it was 59%. 2021, it was 65%. So we're seeing mainstream adoption of Kubernetes for applications in production. And this really shows that organizations are maturing. They're learning how to operationalize Kubernetes. Another interesting trend that we have seen is a shift from deployment from primarily being in on-prem environments to multi-cloud and public cloud environments. So if you interestingly look at this question where people are telling where are they deploying Kubernetes, and the top services you see are managed services from different cloud providers such as EKS or AKS from Microsoft or even GKE. And oftentimes customers are using distributions from Red Hat or VMware to run Kubernetes either on public cloud infrastructure or in their data center. So this clearly indicates that organizations have making different calls. Yes, there's still a lot of them are running on premises, but a lot of them are also considering public clouds and managed services as their options because they want to offload some of the operational complexity of running Kubernetes in these environments to the cloud provider. And also indicates if you draw a correlation from the cloud providers that different organizations are using as well as individual services that they're using for their needs, it shows that organizations today are a lot more comfortable in giving their developer teams and application teams flexibility and choice that they need to decide where they need to run their application first, whether the decisions are being made for where the data sets or where they need to be situated geographically, or sometimes, as Marie mentioned right now, they might be looking for a specific PaaS service, or let's say machine learning services that their application needs. And for that, they may decide, hey, I'm going to be in Google Cloud or a different cloud provider. So very interesting data. And this obviously has a lot of implications on the management and security pieces of how you handle governance in these environments, which we'll cover later today. So, Marie, what are you seeing the implications of organizations using these different services in Kubernetes world from a cost standpoint?
Yeah, so we'll actually be diving deeper into that into the Cloud Financial Management section, but managing container costs is a new trend, and it's a challenge, quite honestly, when it comes to cost visibility, cost allocation, because containers are a shared cost, and many groups within the organization may be utilizing those containers. And so I'll dive a bit deeper into that in a few moments, but definitely an increasing challenge that we're seeing, looking at both the cost of the clusters, the nodes, and being able to allocate those shared costs.
Interestingly,
so, I also have...
Sorry, go ahead.
Go ahead.
I
was going to say...
Looks like there's a lag in audio. But I was going to say, like, it's interesting, right? The dynamics is, of course, benefits and challenges, right? So, as you mentioned, cost being a concern, at the end, on the other end, there's a lot of benefits like resource utilization per se being easier in the Kubernetes world, or organizations finding it easier to migrate to different cloud environments. So certainly a lot of different reasons for which we are seeing rapid Kubernetes adoption across the fold within VMware and our customers that we work with.
Yes, exactly. And that all comes back to the migration strategy, which is a large component of the broader cloud strategy. And so is it, are you refactoring applications, lifting and shifting, utilizing containers? What is the methodology behind those migrations as you are expanding out into public cloud and multi-cloud environments? And so, Nikhil, I actually wanted to pose a question to you about Kubernetes security posture management specifically, and how functionality is evolving in that area.
It's a very interesting domain. Kubernetes security, especially because of the complexity of the microservices architecture and containers, it poses definitely new challenges. Another reason is that a lot of organizations are new. They're managing these environments in production for the first time, so the concepts and the risks that they face are new. So just like, we'll talk about specifically within Kubernetes security misconfigurations, which is an emerging challenge. So we'll cover those in the later space, but it's really emerging as one of the top questions that we're coming from customers. And we're working very closely with them in terms of figuring out what's the best way to tackle Kubernetes security more efficiently and in line with how they're handling security in other parts or other services that they're using to build their applications.
Excellent. And so, we could spend all day on Kubernetes, and I know that topic's going to come up a few more times in this presentation. So I'm going to move on to our maturity model framework. And so, we've mentioned a few times that some of these statistics are based on an assessment that we have on our website. And so just wanted to share what this assessment is based on. And so this is a maturity model framework that has been developed by both the Cloud Health and Cloud Health Secure State teams and refined over many years and many different customer engagements to say, what are kind of the standard best practices that we're seeing and the traditional flow that we're seeing in what we would call cloud management maturity. And so there are three key focus areas, and these areas translate into the broader Cloud Center of Excellence story and really driving that cohesive and collaborative cloud strategy forward. And so financial management is one component, operations, as well as security and compliance. And so I'm not going to read what each of these phases are and the details on the slide, but we're looking at 4 different phases of maturity, and something I always like to call out is that you and your organization can be at different phases of maturity across these 3 areas at any given time. So it's not, you're always in visibility with financial management the same time you're in visibility with security. It could be, you're in governance and automation with security, but still trying to understand who's spending money and what they're spending it on. And so it's really interesting to see the placement of different organizations in those phases. Nikhil, anything you would like to add there?
Yeah, I mean, I think the key point, Marie, is like different organizations have different priorities. Some organizations are more mature on the financial management side, and sometimes they're more mature on the security side. And but the whole idea is what we're seeing is as organizations have run different experiments around governance, what they're realizing is we need to look at these collectively, right? And that's why we're seeing emergence of cloud centers of excellence across the organizations. Because what people are learning is like at the micro level, every team is trying to solve these challenges. Maybe a DevOps team is trying to figure out is their application running in control of their cost, right? Are they meeting their security requirements or compliance policies? So every single team has these challenges, and this is where most organizations have come to an agreement that, okay, we need a center of excellence. We need all of the experts from different fields of financial management, operations, security to come together and actually build a forum with the consumers of the cloud infrastructure and applications so that they can come up with a cohesive strategy. And I think that's the most important piece. Having an alignment on how you're going to mature together in the cloud is most critical for the organizations. So it's very interesting to see how our customers are maturing along this curve. So yeah, why don't you share some data on that, Marie?
Yes, I would love to. And so again, building off of that same assessment, these are the results that we're seeing from the 1,000 plus respondents just from this year alone. And so you can see a large percentage have placed into the visibility phase. But what I find more interesting are the percentages that are expanding to the right of the framework. And so expanding into the optimization phase, the governance and automation phase, and that ultimate end goal phase of full business integration where your cloud is fully operating and aligned to your business goals. And so, for financial management specifically, we're seeing a lot of interest in optimization, and particularly with the pandemic the past few years, there was an increased focus on cost savings. And so many organizations needed to understand, who was spending money, what they were spending it on, how to allocate and charge back those costs. But then the conversation moved forward to, okay, well now how do we optimize and save costs, potentially cut costs in certain areas due to budget constraints, changes in delivery formats, work from home models. Some organizations had to greatly change their sourcing and their procurement and many different processes within the organization. And so that pivot there is really where we're seeing the optimization phase with that 15%. And then moving on towards governance, we're seeing, the policy management come into play. And so it could be as simple as, setting a budget alert, or it could be, more complex of, shutting infrastructure on and off during peak periods, not during peak periods, but on weekends when it's not in use to save money on those costs. Nikhil, what are you seeing on the security piece for the trends there?
It's very similar, Marie. And one thing I want to point out, which is actually missing in this picture, is like what would this curve look like a few years back, right? So if we would have seen this data, let's say 2 years back, we would have seen a lot fewer organizations in visibility phase, right? So that's an interesting shift. What we're seeing is through a combination of cloud-native tooling, through third-party vendor solutions, a lot of organizations now have a better grasp of maturity. Earlier, they were asking, okay, we don't know what our developers are doing in cloud. What are they deploying? I think organizations have felt that's a critical need in order to have that central governance, and most companies are moving beyond that phase. But now they're also asking these deeper questions. So let's say in the case of security, many companies are saying, hey, we do seem, let's say, CIS compliance is a critical standard for our organization. We're supporting 10 different teams, and we've got 10,000 violations. And we are 36% compliance today. So what do we do next, right? So they're already making these calls that, hey, these are the standards that we need to align with. And they're asking questions, how do I engage with these individual developers which are distributed across these different teams? And how do I take those risk mitigation steps? So just figuring out how do you operationalize all of the insights that you're getting from the visibility space to take actions, whether it's reducing costs or buying reservations or actually remediating a security violation. Those questions are becoming very, very critical and often not easy, right? Because the governance is distributed across different teams, and just building the relationships from the central teams to developers is a key challenge. And it's really it's much more than a technology problem. We need to think about what are the processes that we need to put in place before we actually think about the technology that can help us mature along this curve.
Yes, people, process, technology, it's not just a technological focus here. And so those components and the collaborativeness is very important. And we're also seeing some gamification. And so Nikhil mentioned, 36% to a certain compliance framework as an example. But, each of these phases has different KPIs associated with it. And so as an organization, you need to work together to decide what those KPIs are and how you can align to them. And the gamification can come into play when there are multiple different teams. And it can be quite fun to see, which teams are being the most efficient or, reducing the amount of tickets coming in or the amount of violations, things of that nature. And so now I just want to pivot into cloud financial management more specifically. And really, I just want to highlight that there are many names for this market. Cloud cost management has been around for quite some time now. Cloud cost and resource optimization may be another that comes up more often. And then cloud FinOps has really taken the forefront for this market more recently. And so cloud FinOps, cloud financial management, cloud cost management, are they different? Are they the same? And so it can be quite confusing because folks are like, well, which market are you in? And so the answer really is there are similarities across all of these different names, and there's really a lot of cohesion and a pivot point in the industry right now towards certain naming. And so for us, we largely focus on cloud financial management, but we see that as really being synonymous with these other names here as well. And so in some cases, folks often see FinOps as being an abbreviation for financial operations, but we're really seeing it as being more closely tied to the financial management side, as well as just focusing on driving cost-conscious culture and accountability throughout various organizations. And it's really interesting because there are many different reports and analysts starting to talk about this FinOps market, and so this will be a continued trend that we expect to see in this coming year. And so again, going back to our assessment data, there was another question posed in the assessment, particularly around top 3 cloud initiatives for the year. And so just to highlight a few, better financial management, expanded use of containers, there's the Kubernetes again, recurring theme today, as well as the cost savings that I mentioned earlier. And so there are many different challenges for organizations. This is not a fully comprehensive list, but particularly for the cloud financial management area, it's very well aligned to what we're seeing from a maturity perspective of organizations just wanting to improve in this specific area of excellence. And so I just mentioned cloud FinOps. And really there's an organization that is an independent third party that is really taking the forefront in this space, and that is the FinOps Foundation. And this organization is part of the Linux Foundation. And so it includes many different FinOps practitioners. And so those may be personas from product teams, from cloud architect teams, SREs, enterprise executives. Many different folks within an organization can contribute and become what is considered to be a FinOps practitioner. And so as VMware, we are a premier member of the FinOps Foundation space, and we were not bribed to put a plug for them in this webinar, I will say that. But we really see a lot of value in this foundation, and so we are encouraging folks to join us and have open conversations and discussions in there. And the intention of the foundation is not to pitch or put forward specific products. It's really to have just an open conversation about the trends in the market. And it's got a wealth of information on their website, thefinops.org. And so we're really excited to be part of this foundation to see the growth of the programs and the number of practitioners in the years to come. And so just building off of that, we're really seeing a few different trends in the FinOps space, particularly shared cost management, measuring unit costs, and then containers, again, cost management. And so the FinOps organization also puts out their own survey every year. Their new one for 2022 should be publishing shortly. But last year, shared cost management, for example, was the #2 challenge cited on their survey. And while a goal of shared cost management can just be full cost allocation, in some cases it's really just about having a strategy and deciding as an organization how you will handle those shared costs. And in some cases, the cost will not be fully allocated, or you decide a certain support cost is not allocated to a certain group for XYZ reason. And so many different costs can fall into this bucket, containers being one of them, but enterprise support costs, for example, would be another, licensing costs, the Kubernetes nodes specifically, networking, among others. And so really the focus here is on the strategy behind the shared cost management, which teams and stakeholders are getting involved, and how you can account for that in your organization. And so the second is measuring unit costs. And so cost economics, unit cost economics, you may hear these terms coming up more often. And the Cloud FinOps book, there's a book published by O'Reilly Media, and it's supported by the FinOps Foundation. And Chapter 20 is all about measuring unit economics, and it's really referred to as the FinOps nirvana. So really the ultimate goal, the place where an organization wants to be. And so being able to align cloud to your business goals, again, as a key goal for the organization. And so narrowing it down to a specific unit of business or a specific outcome from the product or from the organization or a solution. And so there's a lot of interest in that as well as measuring spend for a particular application. And so we're seeing customers using data to feed into their unit economics practices from a platform like Cloud Health. And then lastly, container cost management. I know we covered this quite a few times already, but really the focus here is on generating reporting that helps simplify the container cost management piece. And so again, just having visibility into those costs can be a challenge, and then the allocation of that because of the cost for the clusters and the nodes and the fact that multiple teams or groups may be utilizing the same containers applications. And then taking that a step further, some organizations are moving into the resource optimization side of containers, looking at it more from an efficiency component as well. And so we're expecting more in these three areas over time and in 2022, and we'd love to hear if any of these are particularly challenging to your organization or of particular interest. So please feel free again to mention it in the Q&A chat window. We'll be happy to connect with you on that. And so moving along, I would love to hand things over to Nikhil to cover cloud security.
Thanks, Marie. So in the security world, right, really the key topic is the talent shortage. I think it's the #1 trend or #1 challenge that all of our organizations are facing. Just looking at 2021, we had a lot of high-profile security breaches, whether those were the attacks on the Exchange server software affecting over 30,000 organizations, or Facebook data breach, which affected over 500 million users through a simple misconfigured database, or the attack on the Colonial gas pipeline, where the attacker exploited the lack of MFA and was able to penetrate the network of the company and actually disrupt the supply chain of gas across many states in the United States. So what we can see is security no longer is just a top of CIO agenda, right? It's no longer a company level conversation. In fact, cybersecurity today is a threat to countries, right? It's a national and economic security imperative. And worsening this crisis is the talent shortage, right? There's a lot of different reports out there. This White House article, news release last year mentioned that middle of 2021, there were roughly 500,000 jobs in cybersecurity space that were unfulfilled. And what I hear is this number is becoming worse. The latest reports show that because of the Great Resignation crisis, these numbers are as high as 3 million. And this is just in the United States. So you can imagine what is happening across the globe. Really, lack of appropriate skill set in an organization can have a cascading effect on security posture. In most of your companies, these champions in information security departments and IT teams, they're responsible for scaling best practices across your entire organization. So when you don't have the right people in those places, right, the risk posture across the whole company goes bad, right? People make more mistakes. So it's really a crisis situation. At the same time, what we're seeing is a lot of public sector and private sector organizations coming together to help boost our cybersecurity capabilities, whether it's governments taking on revamp of cybersecurity frameworks and standards they need to follow across different industries, extending the support to core infrastructure that support our economies, whether those are industrial control systems, especially areas where the cybersecurity and technological advancement has generally been lagging, or the private sector companies coming together and investing in sharing the best practices they have built, investing in ramping up skills across the board. It's great that we're seeing a lot of collaboration in this space, and we do expect that to continue going forward as well. And in terms of security threats that we see out there, one of the top ones that we see, especially in public cloud, is the misconfiguration risk. So this data is based off a report that we published last year out of VMware. And what we saw that in 2020 itself, roughly 1 in 6 organizations, 17% companies, had a public cloud security breach due to misconfigurations. And this is simply just 1 year data. So if you extrapolate and look at the number of companies that could have been impacted in 3 or 4 years, it's mind-blowing, right? Almost each one of our organizations has some kind of a misconfiguration-related incident. And when we asked these organizations, why were you not able to prevent a breach? The reasons were fairly basic. Lack of visibility, lack of knowledge or expertise. A lot of organizations mentioned they're struggling to prioritize how to fix these misconfigurations in these organizations. And especially in cloud, it can be a bit confusing, right? In your traditional software or the middleware cases, right? You have the standardized CVSS score, right? So it's easy to gauge when something goes wrong, and your rest of the organization and the industry captures attention and rallies around fixing those vulnerabilities. But in the cloud world, especially infrastructure, the context matters a lot. Let's say you have a security group with a port 22 open to the internet. Is that something you should worry about? Maybe not, right? If it's not connected to anything, it's not a concern. But if it's connected to a server that has administrative privileges, that's something of concern. So lack of context is really confusing for security teams, especially because they don't own those deployments. So we're seeing a lot of advancement in this space where people are investing in coming up with better risk scoring algorithm, better visibility so that you can understand that context. And certainly an area that we've invested a lot in our own products in Cloud Health Security as well. Now, thinking about the topic of misconfiguration, as we mentioned, certainly it becomes another level of concern as we add the Kubernetes complexity. As we had mentioned, Kubernetes infrastructure is not only an order of magnitude more complex than your traditional application and traditional infrastructure, but it's also the fact where people are running Kubernetes adds to that complexity. So if you think about people running Kubernetes on public cloud environments in managed services, every single cloud provider has their own flavor of Kubernetes distribution and implementation. So let's say if you're in AWS, you might be using more custom resources that the provider provides your developers to have that flexibility in order to build that complex logic for you to maximize the ROI from your infrastructure. At the same time, that's additional layer of complexity that you need to protect and follow best practices. And it's also not very uncommon for your teams to focus beyond your Kubernetes infrastructure. Most applications today will be using some service outside your cluster. Maybe they are pulling data from a database that's sitting in your cloud account, or calling a Lambda function to actually execute on an action that your application needs. Sometimes it's also possible that your Kubernetes infrastructure has access permissions to your cloud account environments. So all of these complex interweb of connections between these different environments can be very, very complicated. So having this unified visibility is becoming another critical need for the customers. So what we are also seeing customers ask for is, like, they don't just need to look at Kubernetes security in context, right? They want to go beyond those silos and look at these connections between different services and manage their security posture more holistically. And certainly a problem that we cater to within our Cloud Health Security solution as well. Thinking about security threats, another area that comes up a lot is IAM security, especially as I mentioned earlier. This is a topic that a lot of security administrators struggle with. especially because the way IAM security model is implemented in different cloud providers is very different. For example, if you think about basic concepts such as a user, in AWS, a user belongs to a cloud account, whereas in Azure and GCP, a user belongs to the whole cloud platform. Similarly, if you think about common terms like role, in AWS, that role actually means a principal. It's an abstraction, something that a machine or an individual can assume and take, assign, leverage all the permissions that have been assigned to that role to take actions. Whereas in Azure and GCP, a role actually refers to a specific set of permissions, maybe a managed identity that a principal can assume. So as you can see, for a developer or an administrator, right, there's subtle differences between security model in each cloud provider, which can be very complex to understand and certainly create more room for mistakes. So IAM security is another area that we see a lot of customers struggle with. And so if you would like to learn more about how the IAM security model differs across each cloud provider, I would definitely recommend you to read this blog post on our website on cloudhealthtech.com, where one of our researchers has written a great article and actually published a cheat sheet on IAM in different public cloud environments. So certainly a must-read for a lot of developers and security admins who are trying to learn more about this space. Another interesting threat area, the topic that comes up a lot in our customer conversation, is supply chain security. And really the sense here is that as an organization, we need to broaden our horizon, right? The environments that we're not trying to protect are not just limited to the application logic that we are implementing within our own proprietary software that we're building. We also need to be considerate of all the third-party software that we're using, whether it's for building our applications or managing or securing those applications. Equally important is all the open source dependencies that we have within our application and in our infrastructure, all the libraries, all the binaries and the frameworks that we're using. So the attack surface is much broader and it's becoming a critical concern. And last year itself, we have seen many security breaches in this space, whether it's Log4j or SolarWinds attack. So these are very concerning for most organizations today. And the interesting piece is, right, oftentimes if you ask an organization or a team, they don't have a good understanding of all of these dependencies that their application and infrastructure has on those third-party or open source software. And it's a complex technology and people process problem, right? Technology is still solvable. For example, within Secure State, we were able to help our customers ask questions if they were running an older version of Log4 or a Java package. But at the same time, there's also a cultural issue, right? As a developer, our mindset is still focused on securing the logic that we have written for our own software, right? We're not yet thinking a lot about, are we using older versions of packaged software or open source libraries? Are there any known vulnerabilities that we should be concerned about? So in order to tackle supply chain security, I think our mindset needs to change. And beyond that, I think we are also seeing a lot of collaboration from different companies, especially private sector companies, coming and investing in this space, encouraging the maintainers of these communities to actually partner with the private sector companies in maintaining and fixing vulnerabilities in those open source software. And we are seeing movements like, for example, Linux Foundation is partnered with CNCF and other communities to actually introduce Supply Chain Security Con as a dedicated chapter to really drive conversations around how organizations can get better at securing the supply chain from a software standpoint. So certainly a key area and a topic of hot interest across the organizations. But at the end of the day, right, if you look at whether it's IAM or Kubernetes, misconfiguration, supply chain, these are all threat or vulnerability signals, right? The real question that a lot of organizations are asking is, okay, I'm getting all of these signals, often noise. What do I do with those, right? How do I operationalize these? And this is something a lot of teams are struggling with. In our own survey, we found that only 31% organizations said that they're aligned on both security strategy as well as how to enforce those policies. Whereas the rest of the companies are struggling. 49% said they're aligned on what the policies should be, but they don't know how to enforce them. 21% are in an even worse position, saying they don't know what the policies should be and how to enforce them. So really, it's a hot topic, and especially this is where DevSecOps become critical for a lot of these companies. And when I say DevSecOps, I actually mean not just the tooling, right, the DevOps pipeline. I'm referring to the cultural change. what we're seeing across a lot of organizations who are struggling to figure out how and trying to actually tackle how to operationalize security, we're seeing a cultural change. We're seeing convergence of security responsibilities across developers, operations, and security teams. What we're seeing that these organizations are coming to the realization that often security doesn't know the deployment context and developers don't know the best practices, so they need to work together. We are also seeing a lot of automation. The level of volume of alerts and signals that they need to respond to is phenomenal, which cannot be handled manually. So teams are trying to proactively embed not only detection but also remediation in their pipeline. Another area that we see is the realization that it can't just all be proactive, right? Most organizations are trying to build some proactive guardrails into their pipelines, but there's a realization that you still need to have a lot of reactive guardrails and detections built in. How are you going to protect all of those brownfield environments that sit out there? Or what happens when there's a drift in your cloud environment, right? So you need a balance of both proactive as well as reactive guardrails, which is very, very key. But generally speaking, there's a consensus that DevSecOps is critical. And as a result of that, we're seeing a lot of consolidation of security tooling. What we're seeing is that organizations are realizing, okay, as an organization, I have many different initiatives going on, whether it's around application security or data security, even around runtime and configuration security. And we can't have 5 different initiatives and trying to build 5 different set of processes, trying to rally the same set of teams around it, right? There's a realization that this tooling eventually needs to converge and provide us more meaningful insights so that we can really reduce the noise and the signals that we're sending to developers so that they can proactively act on them and actually focus on their core work, which is building the applications. So consolidation of tooling is something that we have seen in the last few years, and we're going to see accelerate in the next few years as well. So these are some of the trends that we're seeing in the cloud security space. I would love to hear your observations generally on security as well as broader multi-cloud trends and management topics that we have covered. With that, I think we would like to share with you some key tools that you can leverage, especially those are accessible through the ON24 platforms. Marie, would you like to talk about the maturity assessment that all of our viewers can benefit from?
Yeah, I would love to. So this assessment is available on the cloudhealth.com website, but also available in the ON24 platform in the related content window, so you can access there as well. But if you're curious just about the placement of your organization across the 3 areas of excellence, I would encourage you to take the assessment. And if you disagree with the results or you do agree, we'd love to hear that feedback and get to know more about your organization and your strategy there. And Nikhil, I'll let you cover the State of Cloud Security report.
Thanks, Maria. So it's a research survey that we conducted last year, really trying to understand where organizations stand in terms of cloud security and in particular configuration security. So it covers a lot of different phases of the maturity journey that we covered and goes deeper into the challenges that organizations are facing and what are the best practices that are working. So really encourage you to download this report and give us feedback. Whether you same point, right? Whether you agree with this survey, and if you would like to have a conversation with our team, we're happy to have a deeper dive in terms of what is the state of cloud security in your organization. So yeah, I think these assets are directly accessible to you through the ON24 platform, so you can directly download them. But if you want to grab them later, you can also go to our website, cloudhealthtech.com, and grab those from the resources section, as well as get access to plenty of other resources that we have, including interesting blog articles that our researchers are publishing across the multi-cloud management and security space.
Wonderful. Thank you so much. That was a phenomenal presentation and lots to learn and lots of good questions that actually came up. So I want to welcome back Nikhil on the line as well as Amber to join us today to get to some of these questions that came in as we were listening. So first off, Amber, it looks like we have a question for you. How does CloudHealth help with managing shared costs?
Yeah, sure. First of all, hello, everyone. Thank you so much. Are you able to hear me okay?
Sounding great, yeah.
Sure. Okay, great. So managing shared costs is one of the biggest challenges with cloud cost management, and so this is Cloud Health's bread and butter. We have a tool in our product called Perspectives that really allows us to group all of the assets that are in your environment in ways that are meaningful for your business. So maybe you want to create a group of all of your resources that are for each application or for each line of business or perhaps a cost center. And the Perspectives capability is a robust way to group these assets even when the resources aren't taggable, or perhaps you're pulling resources from multiple clouds, so you can't rely on cloud native tags. And the great thing about Perspectives is that it will maintain these groupings dynamically as you add new resources to your environment in Cloud Health. So with Perspectives, you set them up one time, and then you can slice and dice your data in different ways day after day without recreating or resetting these groups of shared resources. So what this does is it allows you to break down the cost of shared resources by that line of business or by that application or cost center or team, however you want to break them down, so that you can perform a chargeback or a showback, which is really the holy grail for FinOps and for managing and driving accountability really for cloud spending in your organization. So using Perspectives, you can break down all of your resources and costs in ways that make sense for your business and attribute those costs to the groups or the teams that incurred them. I hope that answers your question.
Yeah, no, that answers it quite a bit. It's got to be a game changer. That's wonderful. Okay, and let's look like, Nikhil, we have a couple for you here too. Let's start. How do I get access to the State of Cloud Security Report?
Thanks. Yeah, I think those assets are available as downloadables in the platform itself. But if needed, we can also drop in the links. These are available directly on Cloud Health by VMware website. So if you go to resources, you'll be able to see the State of Cloud Security Report as well as the maturity assessment tool that we mentioned. And alongside that, you'll see a ton of other resources, especially blogs on cost management as well as security best practices. So certainly, if you're not able to download, please check on our website and you'll get access to this report as well as the maturity assessment tool.
Perfect. Okay, thank you. Let's do a follow-up one for you. What are the top best practices for operationalizing cloud security? Excuse me.
Yeah, I know it's a tongue twister, but certainly a very relevant question that comes up a lot for a lot of companies as well as for the senior security leaders. So we did touch upon this a little bit earlier in the presentations, but in terms of top best practices, I think it goes back to people, process, and technology, right? So starting from people, I think the first most critical thing is hire or train or experienced cloud security architect, right? So as we all understand that security is not one person's job, right? So especially within the organization, having somebody who's experienced, who's managed cloud and handled security best practices in the cloud in the past can be very, very handy, right? The whole process can be very complex in most organizations. So if even if you're managing a mid-sized company, let's say, you might have many teams, like within information security department, like GRC, vulnerability management, and others, right? Somebody has to think through, okay, how are these teams actually going to engage and contribute in cloud, and how are they going to get value, and what systems and tools they need. Similarly, they need to engage with other teams in operations to gain access to the cloud environments or work with developers to actually get them to actually fix problems. So having an architect who can centrally think through and orchestrate that process is probably one of the most important things for the company. The second best practice I would call out is like making sure that there are a lot of people involved, right? Making sure that all of those teams have clarity on what their roles are and what their responsibilities are and how they should engage is equally important. And oftentimes, even though it's it's kind of a very common sense thing. It's not easy to accomplish and often missing as we are talking to customers and why they are struggling in operationalizing security. And last thing, as I said, is like it comes down to tooling. And think about, I would say, choose your solution wisely. Right now, especially the cloud environments can be very different from your traditional security needs in the data center, right? Where things are not locked behind your perimeter. So you have to think about, okay, how are you going to scale, right? How are you going to handle distributed teams? Can your solution handle that? How is it going to fit into your company's processes? Does it need to talk to different systems? How are you going to build those integrations? And also think about context, right? Like when you see an alert, what does it mean, right? Does it give you the right information? Does it allow you to prioritize those things? Does it allow you to collaborate with your different developer teams? So all those aspects and evaluation becomes very, very critical. So I would say the third one would be like choose your solution wisely. So I think those are the top 3 best practices. And it's not an easy process. And often what we have seen is the last one I would say is like start small. Most teams try to start with a small project, partner with an individual developer team within the organization, and take it from there.
Wonderful. Thank you. That's Amber, anything that you wanted to add? I know Nikhil covered it pretty well there, but just in case.
Nikhil's the security expert. He's got it.
He's got it. That's what I was going to say. That was a pretty great answer. Thank you so much. Okay. Let's move on to the next one here. During the Cloud Health presentation just a little bit ago, there was reference to a cloud management maturity assessment. Is that something I can try, and where can I find it?
Yes, definitely. It's a great assessment. It only takes about 15 minutes to take, and it will tell you where your organization falls on that cloud management maturity curve. So you'll get a sense of how are we doing in the cloud? Are we early in cloud maturity and just figuring out how to manage our shared costs, or are we, experts at this and we've got automation in place and we're splitting up our costs and we're able to report to the different stakeholders with the information they need. There are a few places you can find this maturity assessment tool. First, you can check out the Cloud KPIs infographic that's attached to this webinar. There's a link to it right in there. You can also access this on Cloud Health's website. So both of this maturity assessment and the security report that Nikhil mentioned, you can find at Cloud Health's website. It's cloudhealth.vmware.com, and you can just go to the resources section there and find us in solutions.
Perfect. Thank you so much. I know we're running close to time here, but we do have a couple quick questions I want to keep sneaking in here. Amber, can Cloud Health help with Kubernetes cost and security?
Yes, absolutely. I'll speak to the Kubernetes cost piece, and then let Nikhil speak to how Cloud Health Secure State manages Kubernetes security. So Cloud Health, what we'll do is, Kubernetes sort of adds another layer of obscurity in managing your cloud costs, because now you've got resources on your nodes, and you're getting a bill for your node, but you're unsure which teams or which applications in your business use those shared resources in the node. So Cloud Health will actually look inside your containers and do that mapping for you. So we'll map back the costs that hit your node to the different business groups that incurred those costs. And I had mentioned perspective grouping before, so you can map those costs to business groupings that you create in the tool. So this will allow you to account fully for all of your container costs, just like you would with applications that are built in a traditional way. So in the platform, you'll manage your containerized or Kubernetes costs just like you'll manage your traditional infrastructure costs. So yeah.
Perfect. Thank you. And here is another one. What strategies
would you like me to?
Oh, yeah, let's let Nikhil answer about this. Yes, please. I'm getting way too excited here. Yes, please, go ahead.
So I think there were 2 parts to that question. The second one asking about security. So as Amber alluded, we have a second product called Cloud Health Secure Suite, which can help with Kubernetes security needs. So just for background, the solution helps with security posture management needs, helping customers reduce misconfigurations, right, everywhere in public clouds, within Kubernetes infrastructure, within those public clouds as well. So yeah, we can certainly help with that. And there's one thing that's also unique is like, because it's a common solution that manages all of your different environments, your different cloud services, IaaS, PaaS, as well as Kubernetes. So it also allows you to sort of have the full context of how your Kubernetes infrastructure communicates with other parts of your environment, whether that's a serverless function or another database that your cluster is talking to. So certainly Cloud Health can help you with those needs, and we've got a pretty innovative solution in that space.
Definitely. Thank you so much, and I apologize for cutting you off there. Let's jump into our next question. What strategies can we use to prioritize misconfigurations?
Oh, that's an interesting question. And I mean, from our perspective, what we've seen is it really depends on the company. One thing that's common is a lot of organizations, they'll start with some baseline standards. They'll look at what are the regulations that potentially apply to their organization. So let's say if you're a European company, you might care about GDPR. So like everybody will start with some kind of a baseline standard that they care about. And CIS and other best practice that a lot of organizations follow. It's kind of a foundational benchmark for different environments. So it's a good starting point. And the good thing is, like, all of these standards, they generally will prescribe, okay, what are the high, medium, low risk concerns. It's a good starting point for most companies. But the other aspect, I think, that can help you prioritize risk is just looking at your asset and data profile, right? Just thinking about where does your sensitive data or most critical information sit. Oftentimes, organizations will think that, okay, I want to focus on internet-facing assets, or maybe I want to focus on my production environment, or maybe look at protect a particular database first, which has my PII information. So just focusing where the most important information sits, I think that's a great way to prioritize. The other piece is also think about like risk context, right? I think I alluded to an example earlier where like having a server that's as insecure as another server or a network port, right? But this one that's not being used or not connected to any sensitive data, right? Those things you can ignore. So like having that context can help you make decisions. And the other piece could be like sometimes it's all as important to prioritize, but also to ignore, right? Just enabling your teams to let you know that, hey, these are the things that they don't care about, so that you can build on those exceptions, whether those are their dev environments or things that they're testing right now. I think that's another great way of just helping them, letting them know that you want to help them prioritize things quickly. So those are just some best practices that we see across customers. But yeah, if you have, if others on the line have seen other best practices, we would love to learn more about those. So feel free to comment in the chat window.
Perfect. Thank you so much. And here is another one. Is Cloud Health by VMware Wavefront?
So I can take this one. So we're not the same as Wavefront, but we do integrate with Wavefront. So if you're using Wavefront to collect metrics around your cloud resources and usage, then we can integrate that data into the platform and use it in our reports.
Fabulous. Thank you. And then it looks like we can sneak in one last question for the day. How can I connect with the FinOps Foundation?
Yeah, I can take that one as well. The FinOps Foundation is a relatively new organization, great place to learn about how to manage these shared resources and costs, collaborate with other people who are trying to do the same things in their organization. If you head over to their website, it's finops.org. And you'll see there they have a bunch of information about events and networking meetups in major cities all over the world. So definitely check out that. I'm actually going to be attending an event of theirs in London on March 28th. So if any of you want to check that out, or if you're in the area, you can come and say hello to me at the Cloud Health booth. And if you are on the FinOps website, take a read through their framework for capabilities around a FinOps practice. It'll give you a sense of what your organization should be able to tackle in terms of cloud cost management. So you'll get a sense of which of these practices you are already employing in your organization and where you stand compared to some other companies that you might compete with.
Awesome. That sounds fun. Hopefully a couple folks can come out to London. That would be great. Perfect. Okay, well, we are out of time for today. I want to give a big thanks to Amber, Nikhil, and Marie for your time today. What an incredible presentation, and thank you for spending some time with us to answer some questions. And with that, With that, it's now time to announce the winner of our random drawing. Let me pull the results up from our team. I am thrilled to announce that Eric Atkinson is the winner of today's EXO Pro Black Hawk drone. Our team will be in touch with you on how to claim your prize. And with that, that is all the time we have today for today's summit. Do take a time to check out those fabulous resources provided by Cloud Health by VMware. We are so thankful to have them sponsor today's event, and they're not resources that you want to miss. And with that, go ahead and take that survey as it pops up. Those results will help us build our future events. So thank you so much, Cloud Health by VMware, for sponsoring today's event, and thank you everyone for attending. We hope you have a fabulous rest of your day.